That means you add different terms together, and the terms, okay, comprises of a non-negative integer. Okay, so all these different terms, it can be a mixture of different powers. X to the power of 5, x to the power of 9. It can be a string of terms. Okay, adding together, we call it polynomial. Poly meaning more than 4 or more. Okay, so if you look at all this, can you see which are the expressions that are not polynomials? Okay, which are the expressions that are not polynomial? Look at the first one. Is it a polynomial? Look at all the power. It must be a non-negative integer. So is this a polynomial? Non-negative integer. Yes, this one integer? Is 1/4 integer? No. So this is not a polynomial. Okay, next one. This one. This one. This one, if I bring it up, is x to the power of -2. So is this a polynomial? No, because this is the negative one. Okay, this one is 3, 2, 1. Okay, so this is the only polynomial. So it must comprise of multiple terms adding or subtracting from one another, but the power must be non-negative integer. So in the examples we give you, it will all be polynomials. Don't worry about that. Okay, so look at this. When we talk about degree, we talk about the highest power that you can find in the polynomial. So here the highest power of x that you can find in this polynomial is 1. Okay, when the highest power is 1, it's a linear expression. Okay, it's a linear expression. Okay, when the highest power is 2, degree is 2, and then we call it a quadratic expression. Okay, this one is highest power 3. Although you have 2, you have 1, but the highest degree is 3. So we call it a cubic expression. Okay, then for quartic, okay, 5 quintic. Okay, but do you need to know the term? Doesn't matter, because they will all spell it out for you. Okay, it's just the special terms for it. Okay, like your normal function, we like to write polynomials like in function form. So we will write p bracket x, q bracket x, or f of x. Okay, but the bracket x doesn't mean multiply by x. It just means that your expression is in terms of x. So we have explained this before when we started our first chapter in A Math. So when they say, oh, can you find f of x when x is a? Then what we do is we will substitute x as a into the equation and then find the value. So when we write this, you must know it means substituting x as a. So these are just some of the notation that we will use for this chapter as well. Okay, the next few pages is just a very simple algebraic exercise. Can we just recap how to add algebraic expressions? Wait for you all to copy. Okay, those who's at page 2, you can sum up 2x squared plus 3x minus 4 to x squared minus 2x plus 5. This one should be easy for you. Page 2. Okay, go and simplify the expressions. All this adding, subtracting, multiplying should be easy for you. The only new thing is dividing. Okay? Can Okay, so this one, find the sum of these two, just add only. Okay, can you do your quick sums? Okay, subtract this from this number. So go and do your quick sums. Okay, I'm subtracting this entire term from 5x squared and so on. So remember to put in your bracket. Okay, that's the only mistake you might make. Okay, all these are simple exercises. Just double check that you get the same answer. Okay, example 3 is the same thing. Just do your replacement. 2 times of px. Yes.
Example 1 with 2x squared.
2, oh. Plus 1 ma.
Oh, I can see that.
Yeah. Okay, just do your replacement. 2p of x plus q of x. And then you simplify from there. Okay, it will be good for you to arrange them in decreasing power so that it looks neater. Okay, but if you never, it's also fine. Okay, all simple exercises. Just practice. Make sure you're okay with that. What's that sound? Okay? Okay, I leave this here for a while. After you calculated, just check. Okay, those who are done, move on to the next page, multiplication. All this, you should be okay. It's just a practice. Okay, check, check. Hashid and Saud, check already. Okay, move on to the next page, do multiplication. Okay, double check. Yep. Oh, you haven't get your tea back. Okay, second period I bring. 2x cubed x squared. Okay, tedious, but just be careful. Okay, this first 3 pages is all your practices. Just warm up your brain. Oops. Okay, this is a quadratic where you try to shift everything to one side and then eventually solve it. 5 and 2. You realize that there's 2 solutions for this equation. Okay, so this is an equation. It is not called an identity because it is only true for x equals to 2 and x equals to 5. Other values of x you sub in, the equation fails already. So there's only 2 values of x that will make it true. Okay, an identity is when it is true no matter what values of x you sub in. So actually there are 2 equivalent forms. So for instance, we all know that x squared plus 2x, if I take out the x, this is the other equivalent form of it. But no matter what values of x I sub into the left and the right of the equation, they will always be equal because these 2 are equivalent form. So when you see such an expression, they call it an identity. It is just equivalent form equations. Okay, then sometimes they like to represent identity with an equal sign with 3 lines. So this is a symbol for identity. So they like to use 3 lines or sometimes they just write equal. So these 2 are used interchangeably. When you see 3 equal sign, don't raise your hand and say got typo. Okay, it's just identity. Okay, so there are 3 special product rules that we have learned, which are very good example of identities. Can you all tell me what are the 3 special product rules? Okay, which is the expansion of a plus b square is a square plus 2ab plus b square. So this is the first identity that you have learned in Sec 2. Then when it's subtraction, okay, so this is the second identity that is always true. And then the very last one is when they are of opposite sign. Then it's just a square minus b square. So these are 3 identities that you have learned in Sec 2. Just that we didn't tell you it's called an identity. It is called a special product rule. Okay, but in A Math, it is an identity. Identity just means whatever value of A and B I sub in, they are always true. Always equal. Okay, so when you are given an identity, you can solve for unknown. So for example, this question, they say these two, this is an identity. They are equal for all values of x. So can you find the values of a and b? So there are two ways you can solve this. Either you expand your right hand side fully. So meaning I go and expand this on my right hand side. I get 2x squared ax minus 4x minus 2a. Then I have a plus b here. And then I equate to this. So this is one way. I expand everything out fully. And then I do a term by term comparison. So what I can do is I will compare my x term. So if I compare my x term, it should be 5. Compare coefficient of my x term. It should be 5 on the left hand side. But on the right, my x term is a minus 4. So this tells me that my a must take the value of 9. Okay, so I can solve for my a by doing a term by term comparison. Same thing, if I want to solve for my b, I'm going to compare my constant term. So constant term on the left hand side is minus 7. And then on the right hand side is minus 2a plus b. So I already know from the first part that a is 9. So I'm going to put it in. Yes, can. Okay, and then this will tell me that my b is 11. So I can do a term by term comparison to solve for my a and b if I'm given an identity. Okay, this is one method. Okay, this is one method that some of you might like. If you are very good with expansion, very careful with your expansion, this is a method to choose. The second method is substitution. You substitute suitable values of x, and then you can get the answer very quickly. Skylar, you okay or not? Okay, so what is the suitable value of x that you should sub in so that you... What is a suitable value of x that you should sub in so that you can get your answer very quickly? So one thing you can look at is this one. I want to remove this, right? Then I will sub in x as 2. So that this thing becomes 0. The whole thing cancels out. Okay? So I will want to sub in x as 2. So that on the left hand side, I will quickly calculate 2 times 4 is 8 plus 10, 18 minus 7 is 11. Okay? So I sub in x as 2 on the left. And then if I sub in x as 2 here, the whole term is gone. I'm only left with b. So very quickly, I already solved for b. Okay, what's the second thing I can sub in is 0. Go. Okay, anyway, I'm supposed to end. Okay, the second term I should sub in is x as 0 because very fast, I can make this 0, left minus 7 only. Okay, then I put in my 0 here. 0 minus 2 is just minus 2. Left an a inside plus b. So this is what I'm left with after I substitute 0. But I already know that b is 11. So I put in my 11. So a is 9. So this is using substitution. The other way is expand and compare. So you see which one you like better. Yes. You sub in x as 2 into this. You press calculator? Yeah. I'm just skipping the substitution part. Okay, so later we will come back to this. You expand out the right hand side fully. Then when you see the x term here is 5, right? The x term here should also be equal to 5. Because the right hand side must equal to the left. Yeah, you compare. Yes. Yes. Later I will run through this again. The method is to do comparison. Okay, the first method is to do comparison. So what I can do is, okay, I will expand this fully. Okay, this one. Okay, find your focus. I cannot afford. Okay, quickly find your focus. Ravan, stop playing with the fan. Take out your notes. Everything is on your table. Okay, so after you fully expand everything, now we want to compare it term by term. There's no point in comparing this because I already know it's 2. Next thing I want to compare is I want to compare the coefficient of the x term. So if I compare coefficient of the x term, I will know left hand side is 5, the right hand side is a minus 4. So to solve for a is 9. Okay, the last one is if I compare my constant term. So if I compare my constant term, left hand side says that my constant term must be minus 7. The right hand side must be minus 2a plus b. You all should have taken your snack break, right?
For this reason, 12:57.
Okay, those who haven't eat, just take out and eat is fine. Yeah, but pay attention. Okay, then you can sub in your a here as 9.
I have no clue.
So you will get b as 11. So this is how you solve for the unknown, knowing that the two sides are equivalent. Yes.
I was gonna ask you.
Yes, I'm going to. Okay, next one is the same expression, but I'm going to deal with it by doing substitution. So I'm going to show you method 2 as well. Okay, look at method 2.
Is there time where the comparing method doesn't work?
No, it's just tedious. Okay, so how to do substitution method is you will choose a certain value of x to sub in so that you'll make the expression very easy to solve. So the first one I want to sub in is I want to sub in x as 2 so that this whole thing becomes 0 and the whole bracket disappears. So I will sub in x as 2 and then you will give me this. Yes. Because this is 0 times this. So it doesn't matter what it is anymore because it will be cancelled out. This whole thing is 0.
Also, you only have b.
Correct. So this will give me 8, 10, 11. So this is substituting values so that this whole chunk gets cancelled out because when 0 multiplied by anything, this whole thing is gone. So I only know b must be equals to this. So this is substituting x as 2. Another x value that you can choose is 0 because 0 makes things easy. This one will be 0. This one will be 0. You will be only left with minus 7 on the left. Then on the right, you sub in 0. This is what you are left with. So you already know this is 11. Put it in. Okay, this is minus 2a. And then you just solve. So a is 9. So this is the substitution method. This is comparing method. You can choose any values of x to sub in. It has to be the same. So remember, because it's an identity, when you sub in an x value, the left hand side should equal the right hand side at any point in time. So this one, you can choose any x values to sub in. Choose the one that will get you to the answer fast. So these are the two methods. Just now I went through a bit quickly. Now can you just take a closer look? I think especially method 2. Okay, then we practice for a bit. Okay, Ken? Can or not? Can, okay, let's do the next example, this one. Okay, there are a lot of brackets there which you can sub in very quickly. So if you want to expand, you can as well, just that it's quite tedious. So I personally don't like expansion. I like to substitute values because it's quicker. So what values of x should I sub in? Okay, x equals to 1. Because if x is equals to 1 here, this one becomes 0, the whole thing gone. This one also becomes 0, whole thing also gone. So actually, if you sub in x as 1, on the left hand side, you get 1 plus 3 minus 2 plus 16. On the right hand side, you are only left with 3c. So go and calculate the value. So this is 18. So c is just 6. When you sub in x as 1. Okay, what's another possible value of x you can sub in? Okay, so if you sub in x as 2, then this bracket will become 0, then the whole thing is gone. Yes, okay. So when the whole thing is gone, let's sub x as 2. When you put in 2, you will get 8 plus 12 minus 4 plus 16. You don't want to write this also can. You just straight away calculate using your calculator. Okay, and then here you will have 4a. Okay, and then here you will have 4c. But you already know c is 6. So put in everything. You will have 32 here. Who? Oh. Hope you have had a good race. Suddenly like, what happened? Or to encourage him. Oh, I didn't have an extra set of notes. I never bring here. Do you have an extra? No. There's one quiz here but dirty, you don't want.
That's fine, it's fine. I didn't even get the quiz.
Yeah, he followed me to the office later. Okay, this one is 8. So A is just 2. Okay, last one. What values of x should I sub in? Yeah, that's why I give you mine first, Ken. I never bring an extra step because I didn't expect suddenly we'll have one more person. Okay, what's the suitable value of x I should sub in? Okay, you can choose 0. Or there is one more value that you can try substituting, which is minus 2. So that the c will cancel out. But if you want to sub in 0, also no problem. So 0, 0, 0, left 16. Okay, and then this one 0, the whole thing is gone. 0 become... You choose any x you want. That will help you to cancel things out. So I choose 1 because all this will be gone. Right? I choose 2 because this thing will be gone. So now I choose 0 because this thing will be gone. So up to you to choose what x values you want. Suitable ones. So you sub in x as 0. These 3 things are gone. Left 16 only. This thing will be gone because a times 0, the whole thing is gone. Any x values. But choose the suitable ones that will help you make the problem easier. Okay? So this one, if I put in 0, I get 4 minus 4b. Because this is a minus 1, this is a 4. For many years, they haven't tested this for O levels already. Yeah, because it's basic. Okay, but remainder theorem, factor theorem, they will test. Okay, so this will give you 2c. So you already know c is 6, put in.
Shouldn't it be plus 4b?
This one is minus 2 squared, so become 4, right?
Yeah.
4 times minus 1 is positive, is minus 4.
Oh, the minus 1.
Yeah. So this one will become... So the rest is just your algebraic simplification. So b is minus 1. So it is just expanding everything out, compare or sub in values and then solve for the unknown. How is it minus 1? This one? Divide by 4, minus 4 on both sides. X is 0, right? So 0 minus 1 is minus 1. So B, 0 minus 2 square, 0 minus 1. So that's why you get minus 4B. Okay, so your expansion, you must be careful.
I'm feeling like really confident for this right now, but in the exam, I don't think I'm seeing this.
Yeah, that's why. Okay, but anyway, this one is just testing your mathematical expansion, how careful you are. So all these practice questions, right? I will leave you to go and try. I will only go through the last 2. This one, 1, 2, 3, 4, 5. You go home and try. I have created a simulator. You can go back and key in this and check your solution. So for example, don't have to worry about that because if I solve by substitution, what values of x can I sub in? What values of x should I choose? Why 0?
You cancel out the...
Okay, I want to get rid of this thing. If I want to get rid of this thing, what should I sub in? 1?
Isn't it 0? Because then the x...
Not 0. No, this one is not q times x. This is a function in terms of x. It is an expression.
Oh, wait, I'm looking at question 7.
How can I get rid of q of x? So that the whole chunk get cancels out. Not 1. 4. Okay, so if I sub in x as 4, this thing here will become 0. So I don't actually care what is q for. I don't even need to know. The whole thing will get cancelled out anyway. So I'm going to sub in x as 4. And then on my expression here, on the left, I get this. Sorry? Can. Okay? And then on the right, I'm only left with 4a plus b, which is a simultaneous equation that I need to solve later. Okay, but doesn't matter. Let's figure out what this is. This one you get 278, a crazy number. Okay, so let's call this equation 1. I can't solve it yet, but no issues. What's the second x value that I should sub in so that my q also get cancels out? Minus 3. So if I sub in this as minus 3, this thing becomes 0. The whole thing is gone anyway. So I'm going to substitute this as negative 3. So I get this as my second equation. So let me calculate.
So,
Yes?
why can't you just sub in the same?
Sub in the same what? Then I'll get the same equation. Then how to simplify things? Okay, wait times 9. Okay, you get a minus 191. Okay, now with these two simultaneous equations, I can solve for A and B. So what I will do is I will use equation 1 to subtract the second one. So 278 minus 191. This is 469. This is 7A, and then my B cancels out. So A is 67. Yeah, many years ago we already know this. Okay, so this is A. So after you solve for A, you can solve for B easily. Just sub A as 67 into equation 1. So B is just 10. And then you are done. So this question, if you sub in 0 just now, like what you all say, right? You will end up cancelling A, but you don't know what is Q0. So you cannot proceed with the question at all. So this question, if you see a function in your expression, in your identity, try to remove it altogether. It is just there to confuse you. You can remove the function if you make the values in front 0. The whole thing will 0 out. Yes.
Wait, so does a function, it must always be multiplied by
Yes. Try to make sure you sub in a value so that the function gets 0 out.
I don't get the 1 minus 2.
1 minus 2? The first equation minus the second one. So 278 minus 191 becomes 469. 4A minus 3A becomes 7A. B minus B gone.
Is this the only method we can use?
This one, you can use substitution also. Make B the subject and formula sub in. Simultaneous, yes. Okay, so question 6, why I want to explain to you is if you see something there, try to remove it, that's all. 1 to 5 is the standard, so I don't want to go through that. Yes, can. Okay, so today when you go back home, try 1, 2, 3, 4, 5. And I think 7 also can do. Okay, so identities, if you go and look at your topical 10-year series, you will see that they put no questions for the past 10 years for 4.1. Okay, so that means they have not tested you this in O levels for the past 10 years. Okay, but it's okay. You still need to have this knowledge because it's the foundation for 4.2 to 4.5. Okay? Can Okay, sorry, 7 you also circle, do as homework because it is nothing special. Okay, now let's move on to division. How to do long division for polynomials. Okay, long time ago, when you were in primary school, your teacher teach you how to do long division. You all still remember? Forget.
Teacher forced me, so I remember.
Okay, so like this example, right? 479 divide by 7. So you start from the, if 4 cannot divide, you look at these two. So you look at the largest times table for 7 that can get rid of 47. It will be 6, which is 42. Right? Then you get 5, bring down the 9. And then look for multiples of 7 that gets closest to 59, which is 56. So left 3. Okay, so there's names for different numbers. So this number that you try to divide is called your dividend. Okay? This number that you are dividing with is your divisor.
Why no calculator?
Okay, the answer that you get is your quotient. Okay, and then finally this number at the bottom, it's your remainder. Okay, so there is an equation that you can come up with, okay, by using these few numbers, these 4 different things. So to get your dividend, it is the same as asking you to use your divisor 7, multiply by your quotient 68, and then plus your remainder. So this thing is nothing new to you.
But Miss Wong, then why are we relearning it?
Because now we are no longer dividing numbers, we are dividing by polynomials. Okay? So meaning the exact same thing. Let's say I ask you to divide this polynomial P.
Why not ask me?
Later, no, not now.
Why not ask me? Don't ask me.
Okay, shh. Let's say I ask you to divide this polynomial by this factor x minus a, for example. Then it gives me this quotient q of x after I minus, and then I get a remainder. So same thing, this dividend that I get is the same as quotient multiplied by my divisor plus the remainder that I have. So this equation is nothing different from what you have here, but just that everything is in terms of algebra. Okay, so now I'm going to show you how to do long division for polynomials. Okay, don't be scared, it's very easy.
May I know the real life?
We learning model method also.
We are learning 2 methods. So I'll teach you both.
Model.
No model. Okay, so first one is they ask me to divide this thing by x plus 1. Okay, example 9 part 1. So I'm just going to zoom into this. Okay, you only focus on one thing. This first one and this first thing. My first mission is to get rid of the 2x squared. So I need to put a number here, so that when it multiplies by x, it gives me 2x squared. So what should the number be?
2x.
Okay, so I need to put 2x here, so that when I multiply by this, I get 2x squared. And then because I also have a plus 1, there's a 2x here. So I just subtract it off. This is my first step. So my first mission is get rid of the first one only. The rest I don't care. So 2x squared minus 2x squared, no more already. So 5x minus 2x, I have 3x now. So I bring down my plus 5. Okay, so next mission, I don't care about what's behind. I only want to get rid of this.
Plus 3
So I need to multiply
by 3.
by 3, so that this gives me 3x. And then the second one is a plus 1, a plus 3.
Why is there a negative sign in front of it?
Because we always subtract it off. Okay? So this 3 is from 3x and 3. Okay?
We just add the remainder.
Yeah, so when we are done, you will get 3x minus 3x, no more. 5 minus 3, 2. So when question asks you for the quotient, it is 2x plus 3. If the question asks you for remainder, it is 2. The 3 is from 3x times 3.
Where's the 3x? Oh.
Yeah, so you must multiply by both of them.
So for every little group, we have to make new.
Correct. So remember, your mission every time is to remove the first one only. Whatever that remains, just bring down. It's okay.
Miss Wong, this is the A math I wanted.
Oh, okay. Can, sure.
This is the A math.
What's the real life use?
Okay, but but this is if they ask you for quotient or remainder, right? But if they ask you to write it in a divisor, this one, they want you to express your result in this way, then you just write accordingly. So they say the dividend that you get is the same as divisor times your quotient plus the remainder you get. So this is another way to write this. Okay, this is another way to write this. Divisor multiplied by quotient plus the remainder will give you the original. Not convinced, go and expand out fully, it should be equal. So I can ask you answers in three ways. I can ask you for the quotient, I can ask you for the remainder, or I ask you for the algorithm. That means give me the expression in this way. Okay, so just make sure you can. Okay, let's practice for part 2 together one more time, then the rest you do. Can. Okay, it is just really long division like what you do, but now it's algebra. Of this one? Not really, it's really logical thinking. Yeah, for this one don't have real life application. Yeah. No. So that you know what is the way to approach the problem, even if we give you an algebraic one.
But you can never use it in real life.
For this one don't have. Exponential logarithm have. Okay? I got video call.
Answer it.
From like CID?
CID.
Joe CID.
For your police force.
What's CID?
Don't know.
Are you a criminal?
Some spam.
Are you a criminal?
No. Okay, let's look at 2 now. Shh. Okay, let's look at 2 now. X to the power of 4. 3x cubed. 2x squared.
I didn't know SPM.
Okay. Shh. So let's deal with it together. No matter how scary the expression is, don't be scared. Just remember your mission is to get rid of the first one.
I'm terrified. For the last question, why do you multiply the 1 by 2?
Last question?
Like you did 3
I failed primary school math so bad.
Because this 3 is for both of them. So it's 3x plus 3, no?
Oh, so you can.
Yeah. Okay, so what should I multiply x with so that I get x to the power of 4? Okay, so x cubed. So this one multiply by both of them. So x4 minus x cubed. So you subtract the whole thing. Yeah. Yes? Yes. So you subtract both of them. So x4 minus x4 gone. 3x cubed minus x cubed become plus x cubed. So you get 4x cubed now. Okay, let me thicken my... Can.
Okay, this one, why you put the bracket?
Because I need to subtract both of them together.
Then why is the minus thing outside?
Because minus this, minus become plus. You need to subtract both of them. Okay? So, one more time. Shh. When I subtract, I'm subtracting this whole thing from here. So, can you please be careful when you minus? This one becomes a plus. You are subtracting a negative number. So 3x cubed plus x cubed become 4x cubed. Yes. Where did the 3 go? Where got 3? This one? 3x cubed minus x cubed become plus x cubed. So total 4. Okay, one more time. 3x cubed minus x cubed is plus x cubed. So total I have 4x cubed left. This thing is gone because I subtract it off already. Okay, now I'm going to bring down the next term. Every time it's a pair. Okay, so remember my goal is to get rid of this 4x cubed. The rest I don't care. So what should I put up there? Okay, so I put 4x squared. So that 4x squared multiplied by x is 4x cubed. 4x squared multiplied minus 1 minus 4x squared. Okay, so this is the thing that I need to subtract off. Okay, so we check 4x cubed minus 4x cubed, no more already. Minus 2x squared minus minus become plus. So negative 2x squared plus 4x squared, I have 2x squared left. Okay, so one more time. Negative 2x squared plus 4x squared gives me 2x squared left. Okay, then I bring down my next friend. So remember, I only want to get rid of this, the one behind, never mind. So what should I put up there?
2x squared.
No, not 2x squared.
Oh, no, 2x.
Just 2x. Because 2x times x is 2x squared. 2x times minus 1. So I want to subtract this off now. So 2x squared minus 2x squared, no more. X minus minus 2x become plus. So 3x now.
3x minus 7.
Yeah.
I get high shit now.
Yes.
This is the A math we need.
Okay, last one. I want to get rid of 3x. So what number should I put up there? Just 3. So that 3 times x is 3x. 3 times 1 is minus 3. So finally, I should be left with minus 4 as my remainder.
Can there be more than one variable?
No, usually it's just 1. Yeah. Can. Okay, so your quotient is this answer. Okay, this is your quotient. Your remainder is minus 4. Okay, but if you want to write it in an expression way, then it is dividend equals to divisor times quotient plus remainder. Yes. I don't need to solve for x. This one is just getting your final expression, your quotient. This is your answer. This is the remainder. This is the expression that is always true.
Has this question came out
Yes, this one have.
every year?
Not every year. Okay? So part 3 and part 4, can you try on your own now? Part 3 and part 4. Algorithm. Okay, it is always your dividend. Wait, my pencil too thick. Okay, your dividend equals to divisor times quotient plus remainder. But remainder sometimes is non-existent, so it depends. So this is the algorithm that we know. If ever during exam you forget, right, then you remind yourself that when you want to find 10, it is 3 times 3 plus 1. So you just have to use numbers to orientate back to the formula that you can get. Okay? So first thing first. If you do long division, like what you do here, very tedious and fast. So I divide by x minus 3. So I will do the dirty work for you. Okay, you don't need to do this, I do for you. So you end up having this, and then you minus 1 of it. So your remainder is 2. Sorry? Oh, very loud. Okay, can. Okay, so if you do this one, you will realize that I put below. Too loud, huh?
You put near the ear.
Okay, sorry. Huh? Yeah, it's a amplifier. Yes, can. Okay, so if you use this, you divide by x minus 3, you simplify, right? You realize that the remainder is 2, and your answer is 2x plus 1. So they ask you, can you calculate what is f of 3? Then we check. We sub in x as 3. And then you calculate. Okay, what does it get you? So what do you think it gets you? How can we relate this to the long division? That's the remainder. Okay? So actually, if I want to divide by the divisor, which is x minus 3, if I make the divisor equals to 0, I'm substituting x as 3. And then it will get me to the divisor, it will get me to the remainder directly. But why is that so? Okay, it's because if I rewrite this, we know the division algorithm, right? If I were to rewrite this, I will get this.
So if you ask for a remainder, you can just do this.
Yeah. So can you see that when I sub in, this is my f of x. When I sub in my x as 3, what am I trying to do? I'm trying to ensure that this whole chunk get cancels off. And then I can get my remainder directly. So the divisor algorithm helps you to very quickly get to your remainder by making your divisor equals to 0. Okay, so I repeat for the second example so you can see better. So same thing. This is my equation. This is my polynomial, my function. And then they say, oh, I want you to do a long division of this thing. Divide by x plus 3. So I go through the long way. I do my x square. So this is x cubed. Okay, you don't need to do this. I'm just showing you. You have done the practice just now already. Then I bring down my 7x. So I get rid of the first one. Then I'm left with x plus 6. So I just take away one of it. And then I'm left with 3. So my gut feeling is this. I know if I were to make my divisor equals to 0, my remainder I will get 3. So I check. Now question say, can you calculate f of negative 3? Why negative 3 is because my divisor is x plus 3. If I can make this equals to 0, then my divisor and my quotient will get cancelled out. Okay, so if I were to rewrite this, like what we have done just now many times, this is my dividend. I can get it by using divisor times my quotient and then plus my remainder. So how can I get to my answer fast? If I can make this equal to 0, then the whole chunk will cancel out and then I can get my remainder directly. So that's why they say sub in f as minus 3. So if I sub in f as minus 3, this is my f of x. I sub in f as minus 3, I put in. Okay, if you calculate using your calculator, it must give you 3. So it gives you your remainder. So actually, this is your remainder value. Okay? So these two examples is showing you if you want to find the remainder for all the examples that you have done just now. Okay, let's say this one. Yes. Okay, this is my example. This is my f of x. If I want to find my remainder, what should I sub in as x? 2. Because I need to make this 0, right? So if I sub in f as 2 into this equation, it must give me remainder 0. Go and check. Okay, it will always be true. Same thing, if this is my f of x, what value of x must I sub in so that it will give me a remainder here? Okay, this one is a different kind of problem. Because this is a quadratic, by right you should factorize it. You got 2 values and you got 2 different remainders. So this one we will deal with it later.
Wait, but then after we factorize it, then we just use one of the values.
Yes. And then you have one remainder. Then another value for another remainder. Okay, this one is the complicated one. I will deal with it later. Yes. Okay, because the only way to make this thing 0 is if I sub in x as 2.
So we make
This one 0.
the divisor.
Yes. If you make the divisor 0, this whole chunk is gone. You can get your remainder directly.
Will the divisor
The divisor?
will it be
Yes. They will always tell you what to divide. Okay, so which brings me to this, a very quick sample. Let's look at first question.
This one, can I go toilet?
Okay. Okay, let's look at the first question here. If I want to find the remainder for this problem, how will you do the question? Okay, let me just put this here. Okay, listen. If I want to find the remainder for this question, what should I do? Sub in x as minus 1. So what you can do is, you can let f of x represent this equation first. Then when you present your answer, it's easier. Okay, then you sub in x as minus 1. Make this 0. So when you sub in, it will give you your remainder. Okay, it will give you your remainder. So you go and put in this. Okay, if you want to work harder, you can also go and do long division for this one. Okay, then in the end, you will also get 6. So during exam, you have 2 options. You can use this substitution way to get your answer directly, or you can use long division and get the final answer. Your choice. Okay, but actually, right, what we are using here is called the remainder theorem. So it's good to cite it by remainder theorem. This is how you get the answer. Yes.
If the question is something like that, can we use the remainder?
Can, but you need to factorize the quadratic first. Then choose one. There will be 2 different values you can sub in. Yeah. Okay. So this is a quick way for you to get remainder without doing long division. Must you always do long division? No. Focus. Okay, let's look at the second one. It keeps repeating. It's the same thing over and over again. Question 2. Can. What should I do? Let this be f of x again. And then what should you do? Let x be what? 3. So you just quote by remainder theorem, like how you use Pythagoras theorem last time. then you will write f of 3 is equal to your remainder value. So you sub in. Just calculator only. Raj. Copy. Why are you playing with that? Okay, you will get remainder as 98. Okay, if I calculate wrongly, then you all let me know. Okay, so it's the same old thing over and over again for the rest of the few examples. Can? Yeah. So when it's divided by x, what values of x will you sub in? 0. In order to make the x 0, you have to make it 0. So for part 3, it's just substituting it as 0. Then you can find remainder. Yes. Yes. You can do long division, you can use this.
But then do they specify you must do the long division?
Rarely. Yeah. Yes. Okay, we will get there. Okay, so this one, I just highlight for you. This one, we sub in minus 1. Okay? This one is f of x. We sub in 3 to find your remainder. Okay, I just give you the method. Okay, then this one, like what we say just now, we will sub in f of 0. Sub in x as 0. Then you can find the remainder. Okay, those who have calculated, what's the remainder for this question? 3? Or haven't calculated? I calculate. Square 7 times 0. Okay, you will get 30. Okay, so the remainder for question 3 is 30. When it's divided by x, is substituting 0. Okay, then this one? Yeah, substituting 4. Okay, what about this one? No, you set this to be equals to 0. It's still x equals to 4. Yeah. Okay, what about question 5? What should you sub in? 1/3. So just always make the divisor equals to 0 and sub in the x value. Okay. So can you calculate the remainder for me? Minus 8 square times 4 cube plus 20 times 4 plus 20. Okay, is it 8? I'm not sure if I'm right. You double check. Sub in as 1/3. To the power of square plus 36. Okay, this one I get minus 5. Okay, you double check the substitution, see whether you get it. Okay, then 5, 6, 7, 8, 9 is a bit different. They have unknown values inside your expression. Okay, they have unknown values inside your expression. And then divisor is not a constant number. So this is slightly different, not your usual question. Okay, but the approach is the same. So I'm going to show you question 6. Okay, question 1, 2, 3, 4, 5. Can you just double check that the answer is correct, okay? Because it's just substitution, I don't think we need to go through. This is 30. Okay, I will just do the last one, question 6. Okay, I know your brain died already. Okay, but let me just complete one so that when you go home, you know how to do the rest. Okay, this is my f of x. Question 6. This is my f of x. I let it be f of x so that it's easy to represent my answer. It leaves a remainder of 4 when I divide by x minus 2. So what is the value of x I should sub in? 2. And then it gives me my remainder 4. This is what the question tells me. They straight away tell me my remainder is 4. So this is by remainder theorem. So I will do my substitution into the equation. So when I see x, I change to 2. Then it is just solving algebraic unknown. So you just solve for A lor, that's all. Okay, so it looks like it's very scary, but actually it's just all algebra.
Oh, and then you get
Yeah. So instead of you finding the remainder, there's an unknown in the expression, you solve for the unknown, that's all. Okay, so same thing for this one. They give you remainder, but you need to sub in x as minus 3k. Doesn't matter, just sub in and then solve the expression from there. Okay, so you go back and then you try. Okay, I know today CCA day, you do what you can. Anything you can't do, we do in class tomorrow. Okay, not homework, but if you can, just practice at the side. Tomorrow we will go through. Let f of x be the expression. So always let it be f of x first. If you like g of x, p of x, up to you. Okay, but define it first. And then they say when it is divided by x minus 1. So which means by remainder theorem, hey, what happened to this? What is this thing? Oh. Okay, by remainder theorem, the remainder I get from substituting 1 is twice the remainder I get from substituting x as minus 1. So this is the statement I want to see. So I sub in 1 now. Okay, so this is the working you can show. Okay, so that's the working for question 9. So the only thing that is different is this statement, and it's translated from this one. Wait, 1, 2, 3, 4. 4 marks. Okay, Can or not? Can Okay, let me take out these questions. Okay, I'm not going to show you the details of the working for the 4 practice questions here, but I'm just going to run through. The steps. Okay, so you know how to manage the question. Okay, let's just look at the steps of handling question 1. Okay, it says I have this expression and it leaves a remainder of 2 when I divide it by x plus 2. So what you can do is you can let this be f of x. Okay, for this question. And then by remainder theorem. Okay, I write short form, you don't write short form. By remainder theorem, when I sub in x as minus 2, it should give me remainder 2. So when I put in 2, I get 4h plus 2k minus 4 equals to 2. And then I get 4h plus 2k equals to 6. So if you want to simplify, it is just something like that. Okay, so you can stop it here first because you don't know what the question wants you to do. Then it says, can you find the remainder of this other expression when it is divided by x minus 1? So you can let this other expression be g of x, for example. Okay, so let this be g of x. Then again, by remainder theorem, g of 1 should give me a certain remainder that I don't know what it is, that I'm interested in finding. So I'm going to just plug in 1. Then you look, you get 3, 2k, 4h, plus 5. So finally you get 4h minus 2k plus 8. Then how to stop there? The question say, can you find the remainder in terms of h only? That means they don't want to see k in your answer. So what you do is, you will make use of this from the earlier part. You make k the subject. So from the earlier part, you know that k is 3 minus 2h. Then you sub it in here. Then you can find your answer in terms of h. So final answer, you get 8h plus 2. Just like that. So this is the remainder for first question. I accidentally solved it. Okay, so no matter how they phrase the question, you just need to know that you just follow the instruction and see what they want. Okay, so that's question 1. Question 2, there will be 2 equations that you need to solve. First of all, you will let f of x be the expression. Okay, I'm not going into the details of the solving. You can solve it on your own later. So just let it be f of x. This is always the first step. Then by remainder theorem, I will write RT lah. Okay. When you divide it by minus 1, your remainder is 7. So this is the first equation you will get.
Is this the same question as question 9?
Similar. The top part you want or what? You want the top part? Can. Okay, so you will form one equation when you sub in x as minus 1. And then you form another equation when you sub in x as 2/3. So using the 2 equations, solve simultaneous. So this one, I'm not going through. You can try it on your own. This one you just solve simultaneous equation. Okay, I will work out all the solutions for this question and upload on Google Classroom. Okay, you can slowly check. Fine? Okay, so that's question 2. Question 3. Let f of x be the expression. Okay, and then it says it leaves a remainder of 3b when divided by this. So by RT, by remainder theorem, f of 1 will give you 3b. This is first equation. Second equation, f of minus 2 will give you this remainder. So again, you will form 2 simultaneous equations, then you solve. So you go and form and solve. I maxed out the screen already. Okay, so I'm telling you the steps. Okay, but you work out on the algebra yourself, ah. Okay, last question. You sub in 1 and you sub in minus 3. They give you the same remainder. Then solve. Then go and find the equation and express answer in terms of A. Okay, this is just the steps for question 4. So all 4 questions, you can note down on the steps and then try it at home. Okay, it's all just algebra. Okay, those who came back a bit later, just take note when it's even power, when you root the answer, it's always positive and negative. 2 answers. Can? Okay, this is remainder theorem. We have dealt with questions when we divide and we get a remainder. We just sub in. But what is factor theorem? What do you think factor theorem is? When you say something is a factor means what?
If something times something, and if it's like divide the quotient of something.
Something is
It divides the number
Perfectly.
perfectly. Exactly. No remainder. So factor theorem is like remainder theorem. You will put in the values of x from the divisor, but it will give you a remainder 0. That means no matter what, it will be equals to 0. So that's the only difference. Okay, factor means you can divide that number exactly. When I say 3 is a factor of 12, 12 can be divided by 3 perfectly. No remainder. So when we use factor theorem, when we sub in the value of x into the function, it should give me 0 because there shouldn't be a remainder. It's a factor. So that's the only difference. Remainder theorem, they always tell you what the remainder is, right? But for factor theorem, they don't need to say anything. You know it's equals to 0. That's the only thing that is different. So which brings me to the next part. This one. Okay, this one same thing. I'm not going to make you do this. We already know that when you do long division yesterday, it was tedious. But I think you also had your fair share of fun. Okay, I just show you, but you don't need to do. A plus 2.
You should just do plus 2.
Wait, I do something wrongly, right?
You should do plus 2 instead of minus 2.
Plus 2?
Yeah. Because you're minusing, so there'll be.
Oh, I
negative.
should minus 1. What am I doing?
Oh, yeah, minus 1.
Then it's plus 1. Okay. Okay? So you will notice that for the long division that you are doing, right? Your remainder must be 0. This one is the only key thing. Your remainder must be 0. So, which means if I divide this is my answer. And it shouldn't give me any remainder at all. And if I write this as using my division algorithm, yesterday we all figured out that is this one times this thing, and then plus the remainder 0. But because it's plus 0, it's as good as no need to write lah. Okay? So how can I get to my answer immediately is if I make this thing 0, and then I will get my remainder as 0. So when you sub in f as half, what you are trying to do is you are trying to make this equals to 0. When you make this equals to 0, this whole thing will cancel out. And what you are trying to find is the 0 over here, which is the remainder by right.
Wait, but we know it's 0, then why are we trying to find it?
Yes, but you still have to sub in the value to make it 0.
No, wait, so what are we trying to find?
We are trying to prove that it's a factor.
We have to do
Oh,
quadratic.
okay.
No need to do quadratic. Okay, so in this case, when you calculate, right, it will always give you 0. You don't even need to sub it in. You know it's going to give you 0 because it is a factor. Okay? So this one, same thing. Actually, you don't even have to do anything about it. You know this will give you 0.
Wait, that's it, that's the working.
Yes.
So that's...
Okay, so this is just an activity to help you see the connection. But the real question is behind. Can we look at the next page? This one. They ask you whether this number or this is a factor of this expression.
So wait, is it just bracket x plus 3, bracket x minus 1?
Yeah. Okay, so first of all, how do we check? We will let f of x be this expression first. So how can I check whether it is a factor or not? I sub in, right? I'm going to sub in x as 3. And then I check if it gives me 0. So I will sub in x as 3. And then I use the calculator and calculate. Can someone press the calculator and tell me what the value is?
This one,
Okay, can you key into the calculator and tell me what the value is? Is it 0? Okay, so if you find that the value is 0, then you can tell me by factor theorem. Since f of 3 is 0, therefore x minus 3 is a factor. Okay, next one you can check is you sub in minus 1. Does it give you 0? Because you want to make this equal to 0, so you have to sub in minus 1. Okay, double check. Does it give you 0? Is what? Minus 20. Okay, so for the second one, after you sub in minus 1, you realize it doesn't give you 0. You can write it's not equals to 0. So since f of minus 1 is not equals to 0, by factor theorem, okay, x plus 1 is not a factor. Okay, later we'll come back and continue with this
Just plugging it into the calculator.
to check whether it's a factor or not.
Easier than
So if there's,
Yes.
if there's remainder, it's not a factor.
Yes, correct. So no matter what, you have to plug in the divisor and check whether you get a remainder or don't have. Okay, so later we come back and continue. I still have one period later. I thought I could start cubic today, but looks like maybe not. But we will see how. What lesson is it now? Oh, chemistry. Oh, chemistry is always after math, is it? Seems to be.
I think it's like
Hi-fi, Grace.
And then there's math after chemistry.
Is it? Okay, see you later.
After outside, you must erase the whiteboard.
Hello, morning. Is this Brandon's father? Yeah, I understand from the office that you need me to return your call. Yeah. They will get back tomorrow. Yeah, then they will bring it home. Yeah. Yeah, thank you. No problem. Bye-bye.呀，这样更惨。嘛，很 disruptive，因为你进去教不到什么，就已经要时间到了。
我跟你讲，
什么？
Justin 我的 I'm back. And his usual self 啊。So Justin, I'm just wondering why your hair is more brown than me. 然后全部人笑哎，因为他的头发 sorry 了，真的太 brown 了。
他染的咩？我不觉得
他觉得
嘞
不。是这样。
Is it？
那男生他们全部在笑，我讲 you should think his hair is more brown than mine.
他真的染咩？
他没有否认。
我从来没有注意过他的头发，
你要不要抓
因为
一下
本来就是 OK，我跟他讲，我跟他的garden 讲，
太 obvious 了，因为如果一点点我就算了嘛。
我 just 跟他garden 讲就好了，因为我懒得跟
Have a chat with him first 啦。
我懒得跟 Justin 讲，没有他的 garden 也拿他没有什么办法的啦。I just let 他的 garden know。
他就一直笑一直笑哎。
哇，他也是一个
好笑了，好笑
啊，
了。
会 lift up 那个班的心情的人了。
我讲 I'm a bit sad because how come your hair is more brown than mine? 哈哈，他就哈哈。But it's okay, I'll talk to your form teacher.
他是 survivor 啊。
I'll let your FT know and ask how come you're like
你可以跟另外一个 FT 讲嘛，不要跟我讲。
可以，我跟你讲，可以。I mean that's easy. I mean it's boys right, you can deal with it 啦。
我跟他不要啦，他接 MC。
哦，OK。
我跟他的garden讲，嗨。
不要跟他聊一聊先咩？
不要。
你这么确定是 brown 啊
我跟他讲
？You
tinted 啦。
see in the morning？
没有他，我跟你讲，我本来都觉得他有一点点那种
有
阿毛色
这个
的，
太有 uniform 了。
就好像 Jamil 我也不会什么管他
Jamil
头发
我 OK
，but 因为 Justin 他每次也是一下，我从来没有看过他黑头发的嘞。
后来这个是
But Justin 有黑头发过没？我没有印象，
浅色吧，没有这个是
会不会脱色？You think he bothers to? No, you think he bothers to go and run his hair? He's so lazy.
I think but he's quite vain, don't you think?
Is he? Did he even comb his hair before? 我觉得他前面那一波是打结的嘞。
Style.
No, he doesn't have a style. 他
跟他就
他跟 Jamil 是好像没有梳头发的两个人。
然后我就跟then Kieran 就讲，就 maybe when you see him at the East Point, maybe he's buying his colored shampoo. Yeah, like 因为我跟他们讲，我 holiday 看到他嘛，他在买 shampoo。
我就顺便叫他 have his hair cut this
Oh
weekend.
yes, get his hair cut too. 我打掉 FD 啊，他没有反对的，
他没有感觉的，我跟你讲
他觉。得他就很 chill，他讲哦 OK。
他每次就这样，我看我叫他剪，他也是剪一点点而已。他们是这样的
小啦。
，but 他小 for what?
Really surprised.
Who is looking at him?
Yes, he has height 啦，and money. 有钱，
有闲。
钱也是蛮。
是 Justin，把他 Q 啦，他 Q。他没有吧？就 I try my best already，他每次我就 OK。
他跟我讲哎，I'm back。气死我好出来。
Survivor 啊，这种是那种他可能去保利那个 tutorial 的时候，老师一直跟他们讲有的没的那种。你看 Justin 有个，然后就那种讲骗话，come out with an excuse。对啦，他去年比较闷闷这样，现在开心，现在还有 Jamil as a 朋友，Jamil 也开心多了。
我看比较亏是没有for，他一直我的问题哦，他每次需要 help 才可以回答。
哦
他真的很 lost。
，but they are all lost, you see.
When I ask Jamil a question, right, I'm actually not looking at Jamil. You looking at me lah, yeah, because you're feeding him the answer.
他们 at least 有帮 each other 啦。
有啦，他帮的这么明显，我都
那
听得到。
你有没有觉得南夏现在没有这么 alone？
有
Kira 会帮他，还是 Degree 还是谁
请？问没有睡觉的时候吗？
就是你没有觉得他像之前这样，没有人很讨厌他，很没有，他比较可以 blend
I
in
think
一
she
起。
finds support in teachers also. Maybe 因为我们没有说很讨厌他还是怎样，so
所以我觉得 OK 了，他坐在那边是对为他好。
我很靠近啊，真的很靠近。But she's okay, she's okay. She
然后
got
就
her
乐一
day.
点啦，乐一点啦。
那又欢迎来 bring my workbook 啊。It's okay 的，你走吃什么？我就 stand up。
这个愿望也是，我还不要紧啊。
我也不想做，我也不想跟他硬碰硬，你懂吗？来，you just stand. Don't need to talk so much. Okay.
然后我好像看我的 lesson time，我们在那边一直 complain。哎，George, you teach us a bit of math first or？
我本来继续，我本来要拖拖。是我很讲完你了。
哦，已经在等了。唉，真的是，然后我很多题没有时间再搬过出来啊！我刚才work out 的 answer 要 upload。
我还因为想讲那个 Canon Engineer 4点来，
所以真的有问题啦，真的有问题啊！
呀，他昨天他们就懂了。
哦。
我说哦 ，OK，
then 你就 just 没有做 anything about it。
这个要害我不讲，可能我还 text 他，等他忙。
唉呀，真的是。 为什么这样多题 ？For which chapter? Oh, maximum minimum. Okay. Mama still haven't. I think I still got a few weeks before I reach coordinate geometry.
I had to, it was a moment of teaching them that you can use AI this way.
Then they okay lah. Like because they rarely will use it on their own, right? So hopefully now they will do some self-help, huh? Yeah, the exposure lah. So by factor theorem, oh then of course before that, let this be f of x first. Okay, then you can tell me that if you sub in x as -2, it will give you remainder 0. Because you know it's a factor that has no remainder. So plug in -2. KH will just be -7, I believe. Okay? So you are using factor theorem knowing that it's always equals to 0. Okay, so if it's remainder, they will tell you what the remainder is. If it's a factor, you know it's 0, they won't tell you anymore. Okay, let me pick out the question. 3. Okay, I will zoom in. Okay, yes. Question 1. Okay, we are. Okay, question 1 just now, right? Take note, it's a determine question. Determine question is like a show, a prove, a explain. So you do not use factor theorem until you prove it. So you can let f of x be the expression first. And then you check. If you sub in x as 3, what will it give you? So this one you need to check. You cannot use factor theorem until you have proven it. Okay, so if you have proven that indeed it is 0. Is it 0? 27 minus 5 times 9 plus 3 minus 12. Yeah. Okay, if you have proven that it is 0, then you say by factor theorem, since f of 3 is 0, therefore x minus 3 is a factor. Okay, you are supposed to determine whether it is or it is not. So you have to show that to me. Same thing, you repeat the same thing for f of -1. Plug in. Okay, and then you calculate. Which is -20, not equals to 0. So same thing, since f of -1 is not equals to 0, therefore x plus 1 is not a factor. Also by factor theorem. Okay, so you need to write the concluding statement to tell me it is or it is not. This one is page 10, page 10. Okay, so question 1 just now we went through already. Just make sure it's a show question. Yes. We need. I did not. Need. Need left let f of x be equals to this. Okay, always define. If they define for you, better. But if they never, you define first before you use. Because if you don't define here and then suddenly here got f of minus 2, is weird. They don't know where it came from. So you have to let it be f of x first before you can use it here. Okay, so define your expression or your polynomial properly first. Okay? Okay, I move to 3. 3 is the same example as 2. Let this be f of x first. Define it always. And then they tell you it is a factor. So you straight away can use factor theorem. So by factor theorem, okay, you know that if you let x be 2, it will give you remainder 0. So with that, you sub in and you solve for h. Okay, 2 possible values of h. Equals to 0. Okay? Can Okay, I realize 4 and 5 is similar. It's very easy. So I'm not going through 4 and 5. I rather go through the next practice question 4. Or should I go through 3? Okay, maybe I do 3 first. Okay, so these two you do on your own. It is similar. There's no trap. There's no new routines. So I'm not going through that. You can go home and practice. I will work out the full solution for you. Okay, let's look at 3 now. This one. Okay, I want to go through some of this. Not all, I'm just going through some of this. Because the context is new to you. Okay, wait . Okay, let me look at 3 first. Just 3. Okay, let me pick out this question. Okay, just 3 only. This is from practice question, not the basic ones. Practice questions 3. Oops. Okay, it says that given that x minus 1 is a factor of this expression, okay, fair enough, you know you use factor theorem. So let f of x be this one first. That's the first step, standard one. And then you use factor theorem. F of 1 is 0. So this is your first step. So it will get 8. 3 plus 5 minus 4. So 4 plus h is 0. So h is just minus 4. Okay, very easy. Nothing different. Okay, but what is the different thing here? Is that they want you to factorize the expression completely. This one. They say, oh, after you find h, can you help me factorize this expression completely? So meaning if you see this being a cubic polynomial, by right, if you can factorize it completely, it should give you a product of 3 linear factors. If you can factorize it completely, you will have 3 linear factors. But sometimes it might be a linear with a quadratic. So when they say, can you factorize it completely for me? You know that one of it is x minus 1. Your mission is to find out what is the other 2 that I can get. So how do you think you can get that out? So do your long division. So this is where your long division comes in, and you want to break the expression up to find the quotient. Yes. Cannot, because there's method given to long division. You cannot use calculator and give me the 3 final answer. Long division 2 marks, final answer 1 mark, plus the first part can go easily 5 marks. So if you use calculator, you only get 1 mark for the whole question. No. You don't anyhow mental. Okay, so using long division, you get rid of the first term. So this one, die must practice. So 8x squared, bring down your minus 4x. Get rid of your 8x squared. Okay, bring down the minus 4. If everything is correct, you shouldn't have a remainder because it's a factor. So if this one is not 0, you know somewhere you have done something wrong. Okay, so that means these 2 brackets that I have here is this quadratic. Then you need to check whether you can factorize it further. So actually you know you can. Okay, so this is your factorize the expression completely. Your f of x is actually this 3. If you tell me that it is this, okay, if you write f of x is this times this, then you don't get the final answer mark yet, because it's not factorized completely. Okay, you need it to be completely factorized. So need to break it further into these 2. Okay? So usually you can have 3 linear factors, but sometimes the quadratic here cannot factorize anymore. Then it's 1 linear with 1 quadratic. Okay? So I want to show this because this is 4.3. Okay, this thing that you are doing here is 4.3. Is what we are learning for 4.3. You are solving cubic polynomials. So when we solve, when you equate this thing to 0, then x is 1, x is 2/3, x is minus 2. That's all. Okay, so actually this one, why I want to do this question here is because in 4.3, they will give you a polynomial at the start, cubic one, and then ask you to factorize it, and then solve it. Whole question on its own. Okay, but it's all linked. Okay, so that's question 3 for you. I uploaded the... this one, yes, I will. Okay, next one I want to go through is 5. 4 is similar to 3, so I won't go through. I want to go through 5 because they give you a quadratic factor. Okay, so I want to address the quadratic factor. So I'm going to go through 5. Oops. Okay, let me bring this 5. Okay, let's look at practice question 5. It says that this quadratic expression is a factor of this polynomial. So no matter whether it's quadratic or linear, we let it be f of x first. Okay, then usually we will sub in values of x such that it will make the equation be 0 with remainder 0. So what values of x can I sub in? What do you think I should do? Can I factorize this quadratic? Can, right? It will be x minus 2, x minus 3. So actually this quadratic is made up of 2 linear factors. When I say I can divide by this, when I say an expression is divisible by this, right? It means on top of the expression, I must be able to simplify. But it also means that if I break this into 2, I should also be able to cancel them separately. Right? If I can simplify the whole quadratic, I can simplify with the individual factors. So if it's divisible by the quadratic, it is divisible by its individual factors. So I can also, using this, say that by factor theorem, f of 2 must give me 0. Form one equation. Then the other one is f of 3 must give me... Okay, this one is minus, right? Did I write something wrongly? Yeah, minus. Okay, so this one is also give me 0. So we go and form 2 equations from here. One is 16. No, 32, huh? 32 plus 8h plus 4k plus 40 plus 12 is 0. So 8h plus 4k is 40, 12, 32 minus 84. So if I divide by 4, it's a minus 21. Okay, same thing here. I put in 3. 3 to the power of 4 is 81 times 2. 162 plus 27h plus 9k plus 60 plus 12. So you can form 2 equations. Plus 162. So 3h plus k. Okay, so these are your 2 equations. 1 and 2. Then you can solve for your h, you can solve for your k. So if I subtract the equation, second equation minus the first one, h is minus 5. Okay, and then k would be plus 10, negative 11. Okay, something like that. Okay, so even if I give you quadratic factor, don't be scared. Factorize it. Each of the linear factors are factors of the expression. Okay, so with that, how can I factorize the polynomial completely? Sub in the h, sub in the k, and then what do you do? Do the long division. So you put your original equation in 2x4. Okay, you double check in case my h and k I count wrongly. It happens. Minus 11x squared plus 20x plus 12 Then you go and divide by this. Okay, do your long division, then you can get your last linear factor or the last quadratic. So 2x squared. Okay, it is tedious, but it is worth your effort because it is 5 marks. What? Not worth it?
Should be 10 marks.
Yo, so greedy. So no need to think, you know, you just work only, just work. 23x squared. I think so. Then 20x. You see, just carry down, no brain work. Yo,
1 mark per number.
too much. 630x. So this is 2x squared minus 10x plus 12. Okay, the very last one is just a 2. 2x squared minus 10x plus 12. Okay, should give you remainder 0. If not, something is wrong somewhere. Okay, so the final factorization of the expression f of x is your quadratic factor and the quotient you find on top, 5. So if you look, because they say must factorize completely, right? You check, this one cannot factorize anymore, then you leave it. But this one, you know you can factorize, so write it this way. So your final answer is this one. Sorry? We need to factorize it so that later, in the later part, when we solve it, it's easy. This will be equal to 0, this will be equal to 0, this will be equal to 0. Yeah. Yes. This kind of question can come up for WA. O level likes this kind. Yes. Okay? Okay. So, right, the remaining question you try on your own. What was the one I circled? I forgot already. All the remaining question 1, 2, 4, 6, 7, 8. Okay, go and do on your own. Example here, they ask you, can you factorize this for me? They say factorize this, right? Then using the sum of cubes above, you can factorize it easily. Because this would be, what is the answer that you will get? So x, 2, x squared, 2x, and 4, right? Because this is a square, ab, b square. Okay? This is a, this is b. A cube plus b cube. This is your a, this is your b. Can you see the a's? A is your x. Okay? B is your 2. So if you just put in your values, then the sign will follow so. Same sign, opposite, always positive. So your factorization is just like that. Don't even need to do long division, don't need to do anything. When you see sum of cubes, you apply so. When you see difference of cubes, these two. Okay, when you see difference of cubes, this 2 is difference of cubes because what is this? This is 4x cubed. What is this? This is 3y cubed. So using the SOAP property, it will also be a square, not a square, a, right? A, b, a square, ab, and b squared. Okay, so the rest will be same sign, opposite, always positive. So your factorization will naturally become this 16x squared, 12xy, and 9y squared. Okay, that's all I have to say today. Okay, so remember your soap, ah. You apply actual soap, then the paper will tear. No, we always follow the same sign. Okay, for the first one. This one is same. Okay, and then the second one is always opposite sign. So if it's a plus here, it's a minus here. If it's a minus here, it's a plus. So this one is the opposite sign. And then the last one is always positive. Yes. Yeah, I'm reviewing what is soap now. Yes. No time. You go during thrive. Okay? So this soap just means, it's just a shortcut for you to memorize how to factorize difference and sum of cubes. So the S here means same. Same sign as what you see in the original expression that you need to factorize. And then this O means opposite. So the sign is opposite from what you are given at the start. And then the very last one is always positive. So that's why this 2 is always positive. So it's just a shortcut. So like what I told you all just now, if I give you this and I ask you to factorize, if you can see a difference of cubes, you can factorize straight away by using this soap. So this is your A, B, A square, AB, B square. Okay? This is your A, this is your B. So I'm just using the formula as what is given above, and then the sign for follow soap. So same sign, opposite, always positive. So this is the factorized form of the 2 cubes. If I give you another set of number, maybe 64 y cube, and then I give you a 27 x cube, then it's a plus. If you can see sum of 2 cubes, then you can apply the formula straight away. This is 3x cube, this is 4y cube. So this is a sum of 2 cubes. Then you use the formula to help you. A plus B, okay, then A square plus, not plus, minus, AB plus B square. So your final factorized form will just be like this. So it's a shortcut. Yes. Plus 12. This one? This one, correct, right? Same sign, opposite sign, always positive. Yeah. Okay? Yes. No. The numbers they give you must be perfect cubes. Not now, later. I only have 35 minutes. Don't go toilet now. You have a snack break before that. Okay. Can So this is just a single application. Out of the past 10 years of O-level, there were only 2 years that they test this. One question. Okay, so it's a maybe have or maybe don't have. So good to know this. If you memorize, you just apply only. So they give you 2 or 3 marks for free. Okay, this one. This is a typical cubic equation question that they want you to solve. So how does it work? Okay, first thing first, the question will say solve. Okay? This is a typical question. Okay, ready? So, when you are given a quadratic, you can solve it easily. But the difference now is we move on to cubic. So when it's cubic, how do we start solving this question? We need to start by trial and error. So meaning, for this cubic equation, by right, there should be 3 solutions. 3 x values that solves this. So we need to find 1, that helps to solve this. So what you can do is maybe you can see that if I put x as 1, right? Can you see that you can't solve it? It's not 0, right? So it's not true. What if you try minus 1? Is it 0? It's 0, right? So how it works is, first step, we will say by trial and error. Okay, first step, always let f of x be x cubed minus 7x minus 6. Then you say by trial and error, okay, I found out that if I sub in x as minus 1, it is actually equals to 0. So by factor theorem, what I can conclude is that x plus 1 is a factor. Okay, so this is the first step. You find the first factor that solves this. Okay, once you find the first factor, then you can do long division. So second step, now is the second step. You will do long division to find the quadratic. So x cubed uh, 4.3. Same set of notes, but 4.3 now. This one, the tick one, 4.3.
I thought you cannot put equals 0 on the expression.
No, I change it to solve this equal to 0. Okay, so I will divide it by x plus 1 and try to solve it. Okay, why did I leave a space here is because in this expression, I don't have an x square term. So later, I don't have anything to bring down. So I just leave it there first. I leave a space there so that I won't have overlap. Okay, so I get x cubed plus x squared, which I need to subtract off. Okay, so the x cubed is gone. Yes?
How long will trial and error do?
Actually, later I'll teach you how to use calculator to get the answer directly. So you don't even need trial and error. It's a fake trial and error. It's like pretend you went through the trial, but actually it's calculator. Okay? So this one, minus of. Okay, it's just that we went through it for you already, but you tell them you trial and error and got this. Okay, so you will be left with minus x squared and then bring down the minus 7x. Okay, so the next one I need to get rid of is this. So I multiply by minus x so that I get minus x squared and minus x. So I subtract the second term. The first one is gone. The second one is left with a minus 6x.
Wait, then the quotient is x squared minus x minus 6.
Yes. So the last one is minus 6x minus 6. It should be gone because you already know this is a factor. So you shouldn't have a remainder. Yes?
Calculator 1, 5, 2, 3.
Yeah. Okay?
This one.
Yes.
For trial and error method, do we have to make a table or can we just write by trial and error?
Don't need to make a table. You just start.
Oh.
Yeah. Okay? So once you have done your long division, actually what you have found out is that this is x plus 1 times x squared minus x minus 6 equals to 0. Okay, this is what you have found out. So if you want to solve for the equation, you can check whether you can factorize this some more. So actually you realize that this one can factorize some more. So these are your 3 factors. So if you want to solve it, it means x plus 1 must be equal to 0, or x minus 3 is equals to 0, or x plus 2 is equals to 0. So this is solving cubic equation.
Wait, this wrong. So
Yes.
You just split the x squared minus x minus 6. You just factorize.
Correct.
Then
So
you
this one is
just- Then
factorizing.
you just use this times this for all real values of x, right?
Correct. So you all remember in quadratic expression, when a times b is 0, a is 0. or B is 0. But now the difference is A times B times C is 0. Means either one of them must be 0. So when you have cubic, you will have 3 solutions. But is it always 3 solutions? Not necessarily. Sometimes there's no solution. It's also possible. Okay, but maximum 3. Okay, maximum 3. Okay, so this is a typical question on how you can solve for a cubic equation.
This one, can you show us how to do it? Or is it how to do it with the
What's synthetic?
The calculator, right?
Is it the same thing but then you go
Yes. Okay, so you see if I want to trial and error, right? Okay, you go and mode, find equation. For polynomial, right, the degree now is 3 instead of 2. Then they will ask you for all the values before that. So just now we had x cubed, so it's 1 in front, press 1 equal to. There's no x squared, so it's 0. And then your x is negative 7, press equal. And then the last number is negative 6. Okay, wait. Then when you press equal, right, you will have one answer being 3. One answer being minus 1. And one answer being minus 2. So when you trial and error, just choose 1. Okay? But some expressions that you get, right, some cubic equation that you have, 3 might not be integers. 1 will be a nice number, then the rest are like decimals. So pick the integer. But this case, you are spoiled for choice. Just choose 1. Yes. No, there will be minimally 1. Okay? So can
What's the 4 number?
4 number, same thing. You'll be polynomial. Yes? Cubic. Then you key in. Okay? Can And then, I think one of you asked this question before, right? They asked me to solve. They asked me to solve. I press calculator, I get the answer already. Can I just give the answer? Of course not. Okay? They give you 3 to 5 marks for this. They want to see your trial and error. They want to see your long division. They want to see you factorizing before you solve. So you cannot just give me the 3 answer and expect me to give you anything. It's no marks at all. You can only use calculator to check your solution and get started on the first one. Okay? So this one important. Okay. Let's do one more. Okay, this one you can practice. We do one more, this one together. Okay, very quickly, you go and use your calculator and find one integer that you can use. For me, it is 6, 2 and minus 1. Is yours the same? 6, 2 and minus 1. If I use calculator, it gives me 6. So you can choose any one you like. So you first let f of x be this expression. This is step 1. Okay? Step 2, by trial and error. So your trial and error is your calculator. By trial and error, when I sub in x as minus 1, so you pretend you really sub in. Then it will give you 0. So you write by factor theorem. Since f of minus 1 is 0, therefore x plus 1 is a factor.
Is this all 1 mark?
Yes, this first step is 1 mark. So you have to write it out for me. Yeah, this one. So you have just found out that this is the factor. Then you can do long division for the second step. So this is your step 1. So step 2, I want to do my long division. So I use my polynomial to divide by x plus 1. Yes. Cannot. This one is 1 mark. Cannot skip. You already use calculator to find the trial. So, don't be lazy. Okay, so bring down the next one. So this is 12x. And then the last one is just plus 12. So your f of x, you have just found it to be this. Equals to 0. So you go and check whether you can factorize this some more. In this case is this. So your 3 solutions are -1, 6, or 2. Although you already know from the start, but you have to show the working. So they say find the real roots. These are the 3 real roots. Yes. Break down the process. Oh, cannot see. Yes.
So the first a plus b is the factor.
Yeah.
And is the quotient.
Yes.
And it's always equals to 0.
Yes, because it's a factor. Okay? So quite clear cut, huh? So solving is nothing different from what you have learned for quadratic, just that you have one more step of long division. Okay, example 4. Example 4 is like, yeah. Yes, before you solve. Which one is from here? This 2 is from this.
But then you won't get negative 8x.
I will, negative 6x and negative 2x makes negative 8.
Oh.
Yeah.
If we don't put the net x.
Then when you write f of x, it doesn't make sense because where did the f of x come from? Yeah. So when you write this, right, it only makes sense if you define it at the start. If not, in the original equation, there's no f of x. So better define it before you use it. Okay? So the steps are very simple. Trial and error, long division, fully factorized, solve. Okay? They give you 3 to 5 marks for this, depending on how complicated your expression looks like. Did they put synthetic anywhere? They never.
1 mark per number.
Okay, they never. Oh, not really. Okay? Can I move on? Okay, wait.
I still don't understand how you get negative 8x.
There?
No, like, how do you get negative 8x to x minus
You
6?
expand?
Oh.
Yeah, so this one is minus 8. Can I? Done, done? Can I? Okay, this one. This one is easy. I don't know why they leave your answer in third form. This one is like I have a few solutions already factorized for you. You don't even need to do anything already. Don't go and trial and error. This one just tell me x is 0. This x also 0. This one is 2.5. Done. I don't know why this question is here. Okay, but never mind. If it's ever given to you like that, most likely it's only 1 mark. Just solve. It's already factorized for you. Okay, the 3 factors that you have, they are all factorized properly already. Don't go and expand trial and error, long division, and solve again. This is done already.
Also, x is just equal to 0 and...
Yeah, because it's already factorized. So don't need to go and expand and factorize some more.
So the factors are just 0, 0, and 2.
Yeah. Okay, this one. Yeah. That's why I think there's some typo somewhere or they changed the question. That's why I don't know why it's asked here. Okay, but if it's asked like that, it's actually very simple, okay? Okay, next. Example 5 is a show question. They say show. So when they say show, you still start off with the same few steps. Let f of x be this first. Okay? And then you do a trial and error. Okay, can you press calculator quickly and give me one solution? Do I have 1 minus 4, 1, 26. Minus 2. Okay, so you only get 1. One of it is minus 2. Then your calculator give you like that. Okay, so when you see these are imaginary roots. When you see I, right? I is actually your negative 1 square in A levels. Okay, so we don't need to learn this. When you see imaginary root means your quadratic got no real roots later. So this is the only one that you can pick. So your calculator will give you a hint how many solutions you have. When you see I, you know that's math error lah. That means there's no real roots. All 3 don't have, no, you will have 1. Okay, so by trial and error, I know that if I sub in x as minus 2, then pretend to sub in like you really trial. Okay, and then show that it's equals to 0. So by factor theorem, okay, you know that x plus 2 is a factor since it has no remainder. Okay, so this is the step you need. Then step 2, you do a long division. Okay, I quick. Yes. We will just do trial and error because it's by calculator. The whole world know it's by calculator. But we still have to write it the proper way. Okay, don't use calculator and get your answer. 13x plus 26. So it's a 13. Zero. So you will get f of x is actually x plus 2. X squared minus 6x plus 13 equals to 0. Okay, now is the showing part. When you solve it, you will solve that x is equals to minus 2. And then x squared minus 6x plus 13 is equals to 0. You are supposed to solve this. So you go and find discriminant. And you realize that b squared minus 4ac is negative. So this part has no real roots. So you have proven that you only have, so f of x has only one real root shown. So actually right from the start when you trial and error, you know you only have one solution already. This is just going through the process. Okay, I zoom. You can also use quadratic formula, but eventually is to show that you have no solution here. Cannot solve on this equation. Your discriminant is less than 0. Why use discriminant? Because if you use quadratic formula, it will give you math error. So how do you explain no solution? You cannot say, oh, math error, right? You must tell them discriminant is less than 0. That's why no solution.
so can you just explain this through discriminant?
Discriminant? B square minus 4AC?
No, like, can you explain this through?
Can. We are supposed to. Okay, so this is how you show that you only have one solution. This one cannot solve. Yes. 13. Which one? 13, sorry.
Remember we used to take a toilet break and then walk across here. Yeah, English.
Okay? Okay, so now I have a way to teach you how to not use long division by using synthetic. Okay, it's a very quick way, but if you don't like it, just use long division, okay? Synthetic, fake division, make up division. Synthetic, fake, synthetic division. Okay, so I'm gonna show you how to do synthetic. Any absentee, no, then I do on the board. Got absentee, so I must record. Okay. Recap. Indices, number deals with numbers. So this is 45. When it's multiply, we add the power up. So this is x5. And then this two, it will be y8. So the first answer I need to see is 45, x to the power of 5, y to the power of 8. Okay, if you got it right, just put a tick. Second one, a to the power of 0 is 1. Okay, this one you change to 1. And then square applies to every single term in the bracket. So it will become a to the power of negative 4 and b square with a 4 at the bottom. Okay, but because they want our answer to be positive index form, meaning the power must be positive, I need to shift this below. Because we learned that if you have a to the power of negative n, you have to bring it down and make it positive. So this thing, I got to bring it down. So you will only be left with b square and then 4a4. Do not bring down the b's. They are two different entities. Yes. The 4 stays where they are because this only affects a. So you only shift a down. The rest stays where they are. Okay? It's not like you push a person down, the other person must go up. It's not. They stay where they are. So this is the answer I need to see.
Wait, which answer? Where is it?
This one.
Okay.
Okay, the rest you can ignore because I don't have the empty paper. I gave out every single copy the other day. Okay, next one.
How much do you still have printable?
400 plus. Okay, anyway, this one. Shh. If you have a negative power, the first thing you want to do is to make it a positive power. And then you flip the fraction inside. So everything in the numerator goes to the denominator. Everything in the denominator goes up numerator. So this is step 1. Okay, step 2. Every term in the bracket should get the power 2/3. The power 2/3. So 8 has power 1. When it's multiplied with 2/3, this is what you get. Okay, same thing. This one will become square. And then at the bottom, it will become 6 times 2/3 is 4. So So this one is 2/3. This one you go and press calculator. It will give you 4. It is not 8 times 2/3. It's 8 to the power of 2/3. So your final answer will be 4 R square S4. So this is your answer. Oops. Okay, sorry for the messy work, but I think you can see the answer. Okay, let me highlight the answer. It's here. And here.
This one you did not write that.
The rest can ignore the rest. Cannot see?
I don't get it.
Every power
Oh, okay.
gets the 2/3. Okay? So chapter 3 will be tested for WA. Make sure you remember all your indices laws. The negative power, the power 0.
But it's
No, you just
negative.
gotta think.
Negative become positive when you flip the fraction inside. These two swap position.
Oh. Oh.
Okay, then you change power positive. Okay? Okay, next question. This one. Using laws of indices help you to find the value of 3K. So first thing first, if you observe carefully, I can take out 3 to the power of 4. So I'm left with 21 here. I'm left with 6. Okay, if you take out 3 to the power of 4, and then this is a 27.
Is that 21 plus 8 or 6?
6. Okay, so this is actually 27. If you observe carefully, 27 is 3 cubed. Okay, so in order to find the answer, when it's multiplied, you add the power up. So K is just 3 to the power of 7. So K is 7. Yeah, first one. Yes. How you compare?
So everything on the left hand side is 2187. And
Then you 3 to the power of 7.
yeah.
Okay, then that's not using laws of indices. Yeah. Okay, so using laws of indices, you need to apply the addition law here by making everything to base 3 and then add up the 2 powers.
Wait, so we can get rid of 1 3.
Oh, because of
Yeah, we extract the common factor first. Yeah, so Jeff, you mark your work, it's all correct. Okay, Next one. This one. Standard form. You want to always make this number to be greater than 1, strictly less than 10. So in order to do that, you need to shift 2 decimal point. So become 2.4938. When you shift 2 decimal point backward, it's the same as multiplying by 10 squared. Because you shifted 2 position. Okay, or 2 place values.
So we just plus
Yes.
the 10 then.
So the 10, 9 I copy down. So your answer is just this. Okay, this is the standard form.
It's okay if we just like do it in our mind.
Can. You don't need to show the intermediate step. You give me this directly, you also get the mark. You use calculator straight away get also can. Okay, faster. Why you all during math must pour water? Is refill bottle.
Yes, Miss Wong.
I look like water cooler.
Miss Wong, hydration is key.
During math,
Yes.
you can do it other period, right?
No, if your brain is dehydrated, it ruins the cognitive function.
I'm tired. Okay, anyway. Shh.
Miss Wong, you should drink some water if you're tired.
This one, we have just found it to be this. But they want you to express this in millions. So actually what you can do is, you can change this to this. Because this is millions. Right? And then they want you to find what is this. So when you have times 10 to the power of 5, they are asking you to shift your place value by 5. 1, 2, 3, 4, 5. So you should get your answer as 249,380 millions. So this is the answer you should get.
So that's a very big number.
Yeah.
What if we do 3SF? We don't need to write times 10.
No need, because they say write it in millions. So don't need to write the times 10 to the power of 6 already. Just change this to millions.
Okay, so what if we do 3SF?
Cannot. Cannot 3SF, give me in exact.
Miss Wong, can you explain it again? I don't get it.
Okay, this is my actual value. I want to express it in millions, means I need a 10 to the power of 6 somewhere, which I will get it from here. So this is the same as 10.5 and 10.6. This is the millions I want.
Oh, okay, I get it.
Yeah. So all you have to do is evaluate this one.
No, because I was confused where you got the 10 to the power of 6 and 10 to the power of 5.
Because I wanted million, 1 million is 10 to the power of
Then
6.
you just
Split, yes. Okay? Can Okay, next one. This one, Ashley. Ashley deposited 6,000. This is the P. Okay, and it's compound interest. The interest rate is R. Find the interest you will earn after 4 years. So this is the T. So the formula for compound interest is given on the first page. It is always this. Okay, or N. Some time period is N. Okay, so let's call this N then. So I put in my P. I put in my 2.8. And then I put in my 4 years. So when you press calculator, you get the amount at the end of 4 years. But to find interest, one more step, you need to use amount minus P. So you must subtract your answer from 6,000 or with 6,000. So you get $700.75. 2 DP for money.
Oh, are we doing compound interest?
Yes, compound interest. Yes, only the interest.
Wait,
Yes.
Miss Wong, we put
Okay, one more time. They say compound interest. So compound interest is this formula given on the first page. So they give me P. P is 6,000, so I sub it in. They give me R. R is 2.8, so I sub that in. And they give me time. The time is 4 years, so I put 4 here. So go and put in the 3 info. You will find A. A is the amount at the end of 4 years in the bank. So after you find N, the question wants interest only. Okay, so you need to use the amount that you earn minus the 6,000 you put in the bank at the start. So this is the interest you earn. Okay, remember money is always 2 decimal place because the smallest denomination is 1 cent.
No, because that money can only be a
Okay? So, yes.
Okay, scroll down a bit.
Okay. So, the first page you see here is chapter 3 entirely. That means I can ask you indices law, all the 9 laws. Then I can move on to standard form, and then I move on to compound or simple interest. So you should expect chapter 3 can ask you all these questions. Okay, this is the rough idea you should be anticipating. Okay, I'm doing revision at the same time because we have really a very short time. You need to revise at the same time. By the time I finish teaching, it's about WA time already. So you all need to revise at the same time. I cannot afford to chiong now and then you all don't know what is going on. Okay, can Next one. This one is the graphical question. Okay, just to point out to you, this is actually 5.1. Although you haven't learned, but the only thing that will be tested for WA is plotting out the curve, because you were not tested out on plotting the other time, right? With the curve. The curve that you see may not just look like this. Okay, but it can look like this. It can look like this. Many different shapes you will see. So don't be shocked if you see a different shape. Okay. Use ChatGPT for this. Okay, anyway. Assuming this plot is correct, assuming this plot is correct, they say, can you use the graph to solve this thing? Equals to 0. So this thing is your y. So when y is equals to 0, go and draw the horizontal line y equals to 0. And they want you to read the 2 solutions. So one solution is here, one solution is here. So, yeah, assuming the graph is correct. So 0.9 or minus 0.9. 2 solutions. So this is part B. Okay? Okay, next one. This is the only thing that will be tested in 5.1, which is drawing a suitable line. Okay? So even if I didn't finish the whole chapter 5 for E-Math, you should be able to do already, because I've taught you all this one the last time. So I'm going to show you one more time. This is what they want me to solve. And my end goal is to make sure that the left hand side of the equation look like this on top. So if you look carefully, I'm very close to this equation already. Very close on the left hand side. So what should I remove so that I can get to here? What should I remove? This is from here, right? This is what they want me to solve. So what should I remove from the equation that is not supposed to be there? The x. So I take out the x first. Okay? Then I'm left with this.
Then the 3, right?
Okay. Then what should I add in?
3.
Yeah, so I should add 3 on both sides. So now I'm happy because I have attained my curve, which is y.
Oh, and then the line is just 4 minus x.
Correct. So the line is just 7 minus x from here. So the line that they want, the suitable line that they want me to draw is this equation. So the moment I see you knowing this equation, you get your mark already. Okay, second is to plot out the line. So you give yourself a table of value and then you sub in any 2x value you like. So example, x as 0 then your y is 7. Okay, then maybe x as 1, then your y would be 6. So go and plot these 2 points out. 0, 7 and 1, 6. So go and draw this line out and then see where it cuts the curve, and that is your solution. So this is the line y equals to 7 minus x. Your solution is 1 here. X is 1.8. And then the other solution is over here. Minus 1.9. Okay? Yes. Where did I get the? I added in so that I can get this thing on the equation. Because my goal is to get my original curve from the top. Oh, it's minus 3 ah. Okay, my bad. Yeah, you get. Okay, so sorry. I never see my eyes. Minus 3. Ayo. So this is 1. So this equation, this one is wrong. Okay, so go and plot out these 2 points. 0, 1 and 1, 0. So your 2 solutions will come from here. Okay, so your suitable line change already is 1 minus x. And then your solution is x as 1. The other one is at minus 1.3. Okay, or minus 1.35. So we will accept a range as long as you are within the accuracy is okay. Okay, so the paper I gave you, right, comprises of chapter 3 and 5.1. So this time round, your WA will have chapter 3, chapter 4 and 5.1. I haven't teach you chapter 4, so I took out the question. But it is actually y equals to mx plus c, which you learn in lower sec.
Will we learn chapter 4?
Yes, you will learn chapter 4 after I finish partial fractions. So chapter 4 for E-Math only has 2 new formula. Y equals to mx plus c, you learn in lower sec. Okay, the 2 new formula is number 1, distance formula. That means how to find the length of 2 different points
Isn't it just
and midpoint. It's just Pythagoras theorem.
Isn't it just like you find the point 1 and the point 2 and then you just subtract?
You take the difference of the x square, difference of the y square, and then square root. That one is Pythagoras theorem, but I will get to that. Okay, so can So we have done 1 round of E-Math revision for chapter 3 and 5.1. Okay, let's look at A-Math. I asked you all to do this, right?
The only thing I can remember is the last one.
Okay, this one you just double check. Oh, easier. So this is 6 times 2, right? When you expand. Then the second one is just this term. Third one is minus 9. And then the last one is plus 3. So this 4 must be correct. And then when you simplify, this is 15. This is minus 11 root 2. Okay, so double check. The answer mark is here. Keep saying ChatGPT, this Skylar. Oh, it's not you? It's Marius, is it? He's what? Nunes. Okay, anyway, this one. You split this. You get 5 root 5. Okay, let me thicken the pen. Like very thin like that. Okay, so I'm splitting the root 125 into this, which can be further split into 5 root 3 lah. Ayo, got error here, is it? 5 root 3. Okay, and then plus 3, and then at the bottom. Okay, this one when you rationalize the conjugate pair. So should be plus 4. Yeah. $25 times 5 is 125. Oh, 5. He's right. I'm wrong. He's right. Okay? Okay, then you go and rationalize. The bottom becomes 25 square minus 4 square. So you get a 20 minus 16. That's why at the bottom should get a 4. Okay?
But these questions are actually doable before. I got 2 to the power of...
Yeah, why?
These are my steps.
Yeah, so become 4 times 5, 20, right? 2 times 2 is 4.
Get that answer.
Root 5 times root 5, 5, correct, right? Yeah?
I got the answer, but then the bottom was 2.
Why?
Yeah, because you factorize.
Factorize what?
You simplify it, 4 should be 2.
So this is 5 times 25 times 5 is 125, right?
But let me just check who's on.
So this is 5 root 5, correct what? Yeah. Okay. Shh. The top, you expand. This one will become 10 times 5, so 50. First term, Second term, 20 root 5. Third term, 6 root 5. Last term, plus 12. Okay, so you should end up having 62 plus 26 root 5 divide by 4. 31 plus 13 root 5 over 2.
Yeah, I got that.
Okay, so just double check your answer. Okay, next one. This one you expand. You will get 4 times root 12, which you can split. So that's why you get 8 root 3. So this one is the simplification. Okay, and then this times this, it's 4 root 18, which you can split again. So it's 12 root 2. Okay, so both you must know how to split them. Okay, and then this one he just copy down. Okay, what you can do is rationalize this piece. So if you rationalize this, you will multiply by root 2 plus root 3. So at the bottom, okay, let me just copy this here. Minus 2 root 2 plus 2 root 3. The minus is outside. I never expand in yet. So the minus is outside. Okay, and then at the bottom, it will be 2 square minus 3 square. Okay, you end up having a minus 1 at the bottom. Which this one can cancels out. So it becomes plus eventually. So final answer will be this one. Okay, this term. Okay, and then these two. Okay, I slow down.
Miss Ron, where is the final answer?
Wait, I haven't reached the final answer.
What is
Okay, so this and this gives me 10. And these two gives me a minus 10 root 2. Okay, so this is the final answer. Okay, I'm sorry, it's untidy because I don't have a blank copy. I'm using Jeff's one. So you see a lot of working here and there. Okay, so again, this one is the expansion from here. This one is from here. Okay, then what I did was I rationalized this piece. Okay? Or totally, huh? Okay, can. Very okay.
Sure, it's better than mine.
Okay.
I told you like half the story.
Should I write it somewhere? Okay, I write at the side. You all cannot see, is it? And square both sides.
Miss Mom, if there's like two squares, can we put one square on one side?
Yes, you are supposed to put
Then
one on each side. Yes. Okay, then shift everything and then solve it. Correct? 6, 4. Yeah. So x is half or x is minus 1.5. Okay, sub in and check whether it makes sense or not.
Miss Mom, how do you get quadratic?
You factorize?
Oh, I didn't square one side.
Okay, when you sub in this, you realize you cannot get 0, so you have to reject. So one is minus 3, and then you end up having plus 6, so 9. Yeah, so this one is correct. So only one solution. This is the one you need to reject because you end up having 2. 2 cannot be equals to 0. Okay?
Do they need like a sentence explaining why it's
No need, you can just reject. If the question asks why do you reject your solution, then you explain. Okay?
Is it y x is equal to 1.5 and negative 1.5?
This one you put in your half, you won't get 0. So it's an invalid solution.
Oh, because it'll be negative and you can't square it.
Correct. Okay? Done? Whenever the degree of numerator, okay, I usually write that, degree of num, okay, is greater than degree of denominator. Sorry? Okay, we need to make sure that it is proper in order for us to start splitting the fraction. Okay, just like when it's 5/3, we will always make it a whole first. So it will be 1 whole and then the 2/3. So when we try to split it up, we need to make sure the whole gets retrieved out first before we really have a fraction to split it further into 2. Okay? So this is the same thing. If this degree is bigger or the same as the denominator, then it is. Okay, so let's just do a quick long division. Okay, and then you subtract. You are only left with this. Okay, and it's done. Right? So we know that if we swap number 1 and we rephrase it to be a simplified fraction, it will be this equals to quotient. This is the whole number answer you get. And then the remainder fraction. This is the remainder fraction. Okay? So this is the proper fraction that you will need to split into its partial fraction. Why proper? Because if you check the highest power here, which is 1, it is strictly smaller than 2. So this is the proper fraction that we will split. Okay? Okay, so same thing here, because this is improper.
Wait, that's it.
Yeah, we haven't learned how to split. So next segment we will split. But now it's just making it into a proper fraction first. So improper, change to proper. Okay, this step is only 1 mark, but it's crucial for the remaining 5 to 6 marks. Okay, so this one same thing, because it's improper, go and do your long division first. Yes.
You know, for the so it's the first portion that is there.
2x, yeah, why?
Then we just don't need to care about that.
This one is just on its own, ma. Just like when you do 5 divided by 3, it's 1 whole and then the 2/3. Yeah, so it's the same thing. We write the quotient first, because this is the whole number answer, and then this is your remainder function with this. Okay, so then this will give me 6 whole plus the remainder function, x squared minus x minus 1 over this thing. Okay, which I'm done because the degree here is strictly smaller than the degree of the denominator. So this is the proper fraction that I've attained. Yes.
Do until we get quadratic.
Sorry?
We do until we get quadratic, or we only do it once?
No, we do until we cannot simplify anymore. Then we will stop. This power is always smaller than this one. If it's the same, we will continue subtracting, right? So if it's strictly smaller, we are done. So don't need to do anymore. This is the improper, and I've just changed it to the proper fraction. Yes. Can the whole number be in terms of x? Can. So like this one is in terms of x. Can. Also possible, but that means the original they give you is a very big power lah. Yeah. Okay. So this is the very beginning of splitting your function into partial fraction. First step is always check that it is proper. If it's proper, you don't need to do long division. If it's improper, do long division first. Why? These two people, I don't know what they're doing every time.
You cannot use synthetic.
Sorry?
You cannot use synthetic.
Not say, but this one is not faster. Yeah. Okay, Ken? Done, ah? Okay, so two fractions here. This one and this one. The two proper fraction that we have, we always want to make sure that the denominator is completely factorized. So in this case, I will continue working this out, but I will want to change the denominator to its factorized form. So this is the factorized form. Okay? So what the question saying is that always make sure that your denominator function is completely factorized. So just now I got this, but I just need to make sure that the denominator is completely factorized. Same thing here. I also want to make sure that my denominator is completely factorized. So when I factorize it, I will get this and this. So always make sure the denominator of your proper fraction is completely factorized. So that I can get ready to split it up. Okay? This one is the combined version. I want to split this fraction back into its original pieces. So these two will be the one that I will split them. So the denominator that you see there will determine how you split it. So now you look at the factor, right? Can you see that here I have a linear factor. Linear meaning the power of x is 1. This is a linear factor. This is a quadratic factor. Okay, that cannot factorize anymore. So I call it the non-factorizable. Can. Yes. Correct. Yes. So these two happens to be both linear factors.
Miss Wang, shouldn't it be x minus 3x minus 1? Because
X minus 3, x minus 1? No, I'm factorizing this piece. Okay, so when you factorize, you sort of can see that if you split it into small fractions, the denominator, one of it might have this, the other one might have this. Same thing for this and this. So they are going to break it into different types of fractions for you. So let me split this further. If it's x squared minus 1, then we can change to x plus 1, x minus 1. But if it's a plus, we cannot split anymore. Okay, this one not the same. So this one will stop here. This one be careful. Okay, so this is the quadratic that I cannot split anymore. If this is the x squared minus 1, then I can split it further. Okay, so there are three scenarios.
factorize it, should it be x minus 3x minus 1? Because you're factorizing positive 3, then you can do it before the positive 3.
Oh, factorize wrongly, huh?
Yeah.
Did I write anything wrongly?
Yeah, it's the x minus 3x plus 1 because you're factorizing.
Oh, should be a minus lah. Okay, that means that one is not factorizable lah. Cannot factorize. Okay, then that means... Okay, yeah, I realized should be minus 3, right? Okay, then this is a non-factorizable quadratic.
So then what do we do?
That means you cannot factorize it anymore. This will be what you write down. That means this is a non-factorizable quadratic factor. Okay, that's all. Cannot split. Okay? Can Okay, next one. Does it work or is how does the scenario look like? Okay, so first step, right? We have done the first step. We always want to check that it is proper. The whatever fraction you are given, we want to check that it's proper. And if it's not, we need to do long division. This is what we have done. We have just done step 1 already. Okay, then what do we do? If let's say whatever denominator that we have is factorizable. So just now, right? We have shown you the 3 scenario. Yes. I cannot. We can only. One is the factor below. They are linear factors. So when you see linear factors, you will split them into separate fractions with the linear factor and 2 unknowns that you need to solve. So if you have 3 linear factors at the bottom, then you split it into 3 partial fractions with a A, with a B, with a C as the unknown on top. Okay? But if you have a repeated factor, meaning, yes?
The previous question,
Noisy, that's why they never on. Okay, next one is when you have a linear factor, but it comes with a square, we call it a repeated linear factor. Okay, when this happens, you will split it into two also. One that is linear, one with the square. So this is like a template. You see this, you split it into these two. So example, if my fraction is like that, if my proper fraction is x plus 1, x minus 2 squared. Okay, I have one linear here, right? So they tell me that if linear, I split this into this. Okay, I have a repeated linear factor here. So they tell me I need to split it into one of it and the other one with the square. So when you have a repeated linear factor, you split it into these two. Linear is just this one. Sorry? This is how it is. They tested it and realized that every time if I end off with a proper fraction like this, originally it came from this. Okay, so there will be one linear and one with the repeated. So you split it into these two. This one they tested and proven that it's always like that. Yes. It's just you see the denominator, you split it. So you see linear, you split it into one. You see repeated, you must form two fractions.
But why is there a 1 as a square root?
This is the pattern they tell you. It's like a formula. I give you quadratic, then you apply the formula. Now they are telling you when you see a fraction with a repeated root at the bottom, when you split it up, originally it came from these two. So it's like a plug formula. They are telling you when you split it back up, these were the two original factor you get. Okay? But the last type is if you have a non-factorizable quadratic. This one. Then when you split the fraction at the bottom, it is your quadratic factor, but at the top, it's a linear unknown. Okay, so this is the linear unknown. So this is the only one. Okay, now you see it as formula, so it's a bit difficult to understand, but when we see real examples, it gets easier to visualize. Yes. Because when we have a fraction, the top of it is always 1 degree less, usually. Okay, so we see this one we can keep it first, but I'm just telling you. You see just now, when you see quadratic, you split it like that. It's standard. It's like a template. You see this, you put it into this. So that this is how we are going to split it. Okay, first of all, this is the fraction. What is the first step we need to do to check? What is the first step? Do we split straight away?
No.
We check what? See whether it's proper or not. So highest degree here is 1. The bottom is a x squared. So is this proper?
Yes.
Then we can start to split already. Because it's proper, we are done. So when we split, we look at the linear factor below. 1 is x minus 1. So you know that one of it looks like this. I don't know what's the number on top. That's for me to solve. Okay, and then this other linear factor I have here, I will split it into the second fraction. And the unknown is for me to solve. Okay, then you end up seeing like your E-math algebraic fraction. So to simplify and solve, we will multiply everything by LCM. Remember E-math? We want to get rid of the denominator. So when we do that, I'm only left with this on the left hand side. This one, I'll be left with A times this. Okay, and then the last one, I'll be left with B times x minus 1. So this is building on your foundation from E-math. Yes. Can. Then after that, you also need to drop the denominator. So also can. If you want to combine the two into one fraction, then compare the left and right also can. So once we reach this step, this is like your identities in 4.1. Okay, once you have your identity in 4.1, You can expand everything and compare, or you can do substitution and solve. Oh, this one is always plus. When we split this up, we always write a plus here. If it's a negative value, the b will take negative. Then later it will become negative, so it's okay. So that one in the middle, when you split the fractions up, in between is always a plus first.
Oh, then later.
Yes, later it can become a negative. Okay, so when I solve, it depends on what method you like. You can do substitution, you can do comparison. So if I substitute x as 1, then I will get negative 12 on the left hand side. And then this one becomes 0. So B is, A is just, for A is just minus 12. So A is negative 3.
After this, are we doing coordinate?
Yes. Okay. Then when we sub x as minus 3, we will get minus 48, minus 60, minus 76. Okay, I think so. Then this is the one that becomes 0 now. So I will get negative 4b. Okay, I think so. You check the calculation. Okay, but once you are done, put the A and the B back into your fractions. So what they are telling you is actually that fraction you see there can be broken up into its two partial fractions that looks like this. So if you are not convinced, you go and expand this, combine, you will get the fraction on the left. Okay, why we need to do this? We work so hard to combine them, now why we want to go backwards again? Because in Sec 4 when you learn integration, you can't integrate this function, but you can integrate this. Okay, so you need to split it back into its partial fractions so that you are able to integrate the function to find area under graph. Okay, so now you don't see the purpose, why split back to the original, but it's for the later chapters. From here, I just put in my A value and put in my B value. Yeah. Okay, so this is the two partial fraction that you have attained. So don't be happy once you get the A and B, you stop there. You have to show me this final line.
How many marks is there?
5 to 6. No. Quadratic is the most. Okay, there are certain chapters that you can apply in real life. There's applications of it, right? But for this one, of course, you can't see it. So any other mathematical topic that you encounter is to train your problem solving skills. Okay, when you see a problem, you examine the givens and then you try to come out with steps to solve the problem. So in real life, any issue you face, you need to find the math behind it, break it down into steps, find the method to solve it, and then eventually do it. So it's to train your mathematical thinking. It's not just the context itself. Okay, this one. Is it proper? Why negative? This one correct, right? When I divide by negative, correct, Okay. Okay, this one, this fraction, proper, improper? Highest power is 1. The highest power below is 2. So it's strictly smaller, it's proper. I can start to split it. So I'm going to split this into 2. But the bottom, I need to factorize first.
So if it's improper, we only have to do one more step.
Yes. Okay, so you check, make sure it's proper. And then make sure the denominator is completely factorized first. Okay, once the denominator is completely factorized, then you will start to split it. So this is one linear. You will split it this way. Okay, this is the other linear. You will split it into the other fraction. Okay, just like that. Then the rest is solving your unknown.
Will we ever have square?
Have. That's where you have the other scenario and you split them differently.
3 plus.
Which one plus?
The below the B.
The below the B, plus 2i, yeah. Okay, yeah, so next step, of course, we like to change it into non-fractions. So we multiply everything by LCM. So left with 35x minus 14. This one left with x plus 2. Okay, this one left with 3x minus 1. Okay, online they call this the cover-up method. Basically, when you multiply this in, they just say cover this lah. Then that's why you're left with this. Okay, this one multiply with this, they say cover this up. So that's why you're left with this. Okay, then this one multiply with this, you cover this up. That's why you're left with this. So they call it the cover-up method. Okay, but it is expansion. Okay, so the second step, you can choose to compare or substitute, up to you. So if you are the type that you like to fully expand, then you will end up having this. Okay, I just show both methods. So if you like to compare, you will end up having a simultaneous equation. So compare coefficient of the x term, which is 35 here. It is a plus 3b here. So this is first equation. Okay, if you compare the constant term, then it will be negative 14 here, and you compare it with 2a minus b. Then you solve the simultaneous equation. Okay, I thought substitution is easier because you can straight away solve for b, straight away solve for a. Okay, but if you prefer this one, it's also fine. So I will multiply equation 1 by 2. Okay, then you sub b as 12 into 1. Okay, if you prefer solving this way, this is the other method. Okay, so this is by comparing. That means you expand everything fully out and then you compare the x term together. So the x term here is a plus 3b, you compare it with 35. The constant term is 2a minus b, you compare it with minus 15. Then you solve simultaneous. So this is tougher, right? Because you need to do more mathematical steps.
I use substitution.
Substitution. So I'm telling you, you can use substitution, like what we did up there. You can do comparison, like what we do at the bottom. You can mix the two methods up. Some compare, some substitute, also can.
Why did I go wrong?
I don't know if I did something.
Why is different? Minus 6 minus 1 is minus 7.
Oh, oh yeah.
Yeah.
Oh yeah. I thought it was multiply.
Yeah, so it's minus. Okay, so final answer. You will get this.
Minus 12, I got 56.
Okay, these are your two partial fractions.
This one, I think I did something wrong because I did not get that.
What do you get? Yeah. This one will be gone. 3 times 1/3 minus 1 will be gone. Yeah. Yes?
So you were talking about the partial fraction.
Yes.
So just to clarify, if the top power is bigger than the bottom power,
You do long division first. Split already, then the partial fraction you split.
but if the top one is smaller than the bottom,
Then you can start to split already. Yeah. Okay, this one. This is the repeated one. So first thing you check is it proper? So this one, the highest power is 1. But this one, the highest power is a square. So it's proper already. I can start to split. So just now they tell me if you see a repeated root, this one repeated, you will split it into 2 parts. One with the linear, without the square, and the second one with the square. So this is how the formula tells you that if you see a repeated root, split it into these 2. Then you start solving the question by multiplying throughout by LCM. Okay? So first one, if you multiply, left with this only, simple one. Second one, you cancel one of the bracket. Last one, the whole thing is gone, just left with B. So this question, you can do compare, you can do substitution, up to you. Both are equally simple. So if I do a comparison, if I compare the x term, compare the coefficient of x, I know that 2 is just 8. Okay? And then if I compare constant term, on the left is 3, on the right is minus 4a plus b. I already know a is 2. So b is just 11. You compare. Just compare the x term. They should be equal. Yeah.
For the subbing in there.
Yes.
There's nothing for B, so I always sub C.
So nothing there, so you just be b.
So how do we find A?
You can sub 0, sub any other x value.
So if we sub 0, then the B will be.
Yeah, so the first thing you solve is you sub 4, then you can solve for b first. So you already know b. Then you sub another value.
I thought there'll be C also.
No c. Because there's only a repeated root. A repeated root only has these 2 parts. So no other fractions already, only these 2. So your answer would be 2 over x minus 4 and 11 over x minus 4 squared. Okay, so this is how you can split it into 2.
So if it was like x minus 4, then x minus 4 squared,
Yes.
then there'll be 3.
Yes. Okay, so if it's repeated root, this is how you will split it up. Harini, okay not? Tired? You no need to copy anything. Okay, you feeling okay? Oh, why? You okay? Okay, this is scenario 2 when you have repeated factor. The last type is non-factorizable quadratic. Okay, so partial fraction should be okay. You just need to be careful. A lot of algebra. That's all.
So when I find the B, can I sub in the 11? Will I get the answer?
Sub in 11. You will find B first, right? Yeah, you sub in the 11, then you can find A. If you do substitution, right, the first thing you sub is x as 4. So you will get 11. B is 11. But when you want to solve for A, you realize I don't know what value to sub. Just choose any other x value. So let's say 0. Then it will be 3 here. Then it will be negative 4a plus b. The b I already found. So I put the b in. And then my a will be 2. So when you don't have any suitable value of x to sub, you can think about 1, 0, minus 1. Small numbers that you put in. It will still form an equation. Then make use of what you have solved. Sub in to find the other one. So if you are doing substitution method, then this is what you can do.
So we sum x at 0.
Ah, yes.
Then we use a to find.
Correct. Okay, you want to mix and match also can. Can partial fraction. This chapter, the only difficult part is factor theorem, remainder theorem. Sometimes they can make it difficult for you. But other than that, it's all about algebra. Make sure you are careful. This is Ashfield, you 6, 7 behind. Can? Okay, let's move on to the next part. And play. This one. First step, check. Is the highest degree smaller than the highest degree of denominator? Here, when you expand out, you get an x squared. Here, you got an x. So when you expand it, the highest degree must be an x cubed. Okay, you can check it mentally. Don't need to expand it out fully. Okay, so you know this is proper. There's no need for you to do long division. You can start splitting this thing up. So I'm going to start splitting this thing up into its partial fraction. So first one I look is I got linear.
For the last question, a equals
So linear, I put it like this first. Okay, linear only split into that one thing. Okay, then I have a repeated. So the repeated, I need to split it into 2 parts. One with the x minus 2 on its own. Next one with x minus 2 squared. So can you see that my repeated, there's 2 parts to it. My linear, there's only 1 part to it. So altogether, you should split it into 3 partial fractions according to the factors you have. Okay, then of course the next part is to make everything into non-fractions. So you multiply throughout by the LCM. Okay, so when you do this, the whole denominator is gone. Okay, when you do this, only the linear is gone. Well, I feel like I'm in a jungle. You all hear the...
Wait. Where do we put an x in front of
What x in front?
the x bracket 2x plus 1 bracket?
Why?
When do we put x and when do we not put x?
This one we don't put at all. The quadratic then we'll put.
Oh,
Yeah.
that's a type.
Yes. So this one, next one it's the b. So I multiply this one. I cancel one of it off. So this one will be the one with 2x plus 1 and x minus 2. Yeah, it's getting louder, right? I really feel like I'm in a jungle. Okay, so the last one. Y'all saw the video about the cicada in Tampines, infesting Tampines residents? I think so is that one. Okay? So this will be the identity you achieve is like 4.1. Then you will sub suitable values of x to help you to solve. So this one I sub x as minus 2, no, as 2. Then I will get 36 plus 2 plus 7. This will be gone. This will be gone. I will be left with 5 c's. So 38, 45. So C is just 9. So this is one value you sub in. The next one you can choose to sub in is minus half. So So when you sub in minus half, this one you get what? 9 over 4. Half plus 7. Then this thing will become 0. This thing will become 0. You are only left with A. Minus 2.5. 5 over 2. 25 over 4. Okay, then you calculate. I got calculator now. What is A? 1.4. Fraction?
6 1/4.
What? 6 and 1/4. So 25 over 4. Is it? No, what's the final answer for A? 1.4. So 1 whole, 4 over 10, 2 over 5, 6 over 5,
This one.
7 over 5. Aiyo. Okay, leave it in improper fraction because later when you sub back, it's better to be improper. Okay, last value to sub. Yes. Because when you plug it in you don't want decimals to be in a fraction. It's non-simplified. Okay, you want to put a fraction back in. Okay, last one is to sub x as 0. So I will get 7 on the left hand side. Then 4a, but a I already know is 7, 5. Okay, then I have b. B would be 1 minus 2. So minus 2b. Okay, and then C is 9. So sub in C as 9 also. So what is B after you solve?
All this to get 2 marks.
Oh no, it's more than 2 marks. A typical proper fraction, partial fraction question can be 6 marks. Sorry? No. First one is you splitting it up. Okay? They already give you marks for splitting it up. If it's improper, they give an extra mark. Okay? And then your method here, 1 mark. Whether you use substitution or comparison. Your 3 unknowns, 2 to 3 marks. And then the final answer. Minus 2b. Minus 2b. Yeah. This one different answer, is it? Ayo, I use calculator and check.
Is it A correct?
Is A correct?
Yeah.
9 over 4.
Is correct.
Correct what? Okay, then times 4 plus 9 divide by 2. So is the answer 19 minus 19 over 5? No? Correct, right? Positive ah? Okay, wait, I do again. 4 times.
Miss Huang.
Yep.
The A is 35 over 4, not 25 over 4. No, the top one, not
25,
the bottom.
right?
The top one.
Is it 25?
35.
It's 35? No, this one is correct what? This one is correct, no problem.
It's 35 over 4.
Yeah, it's 19 over 5. It's positive 19 over 5.
Okay, so the only thing is positive lah. Okay, can. So once you know this ABC value, now the challenge is how you put it back into the fraction. So when it's an improper, when you put it in the 7 over 5 here, right? Don't put the whole 7 over 5 on top of the fraction. The numerator is at the numerator, the denominator joins the denominator. Okay? It's just like you do this. Okay? So that's why when you combine it, this is what you get. Same thing for the B. Okay, and then the C is just 9.
What easier part of the chapter?
And then for me, you can just suck again.
Yeah. Okay, so when you put it in, you don't want you don't want decimals, you want to put the improper back in. You also don't want mixed number because you cannot put it back in nicely. So this is the only way. Okay, right? Okay, so what if we have a linear, this one linear, we will put like this. Okay, you check first, it is proper, so we can split directly. Okay, then now this is the different one. This is the quadratic that cannot be factorized anymore. So when you see a quadratic, at the bottom, you write the quadratic. At the top, it's a linear function. So if, oh sorry, this is the A, right? So you already use A, right? So the next unknown you use is B, X plus C. It must be a linear unknown. Okay, so the top part is a bx plus c. So you need to solve for a, b, c also, but just that there is a x variable here. So when you split, make sure when you have the quadratic, you have to split it this way. This one. Okay? So now next step, same thing, multiply everything by LCM. So first thing, this thing is gone. Okay, second term, when you expand, the x cancels out. So you are left with this.
Wait, this one, maybe I explain the thought process again.
Okay, it's just like I set it, then I put this in. Yes, it's like this one will pop up for you to solve. So the pop-up is from you. I wrote plus 2. Minus 2, right?
Yeah, so
I sub in wrongly.
the function is
Yeah, doesn't matter. That means B takes minus 2 lor.
This one, can you give us homework this year? I mean this today.
Give your homework today?
Yeah.
Of course I will.
It's gonna be the only homework I can ever do.
What only? Okay, then last one, I cancel this out. So bx plus c times the x. Okay, so this is again like your identity from 4.1. You can expand and solve, or you can compare. So it does seem that actually for this question, I can do some comparison if I want. So ax squared plus 5a, bx squared plus cx. So what I will want to try to solve first is, of course, the constant term, because I only have one unknown here, so I just compare lah. So I compare compare coefficient of x. It's 3 equals to c. So this one has some value in the expansion because it's easy. Yes. 5 plus a equals to 5. So, okay, if I look at the, yeah, correct. So, constant term is this thing equals to this. So, you compare constant term, it will be 15 is 5a. So, a is just 3. Yes. Why is it bx plus? It's just an unknown, but must have a linear x there. That means on top could be 3x plus 5. On top could be 7x minus 1, but I just don't know what the two constants are. But at the numerator must be a linear factor. Yeah, because all those at the bottom you are already power 1. But this one is a power 2. So on top of the fraction must be a linear. Yeah.
Not below that.
Okay. So this one, last one is we will solve for the unknown b, right? So if we compare coefficient of x squared, coefficient of the x squared term, it will be 5 equals to a plus b. So a I already know is 3. So b is just 2. So in your final answer, you will put back the values here. So a is 3 over x. Then your b is 2. Your c is 3. So on top of the quadratic is a linear function. So you just put back your a, your b, and your c. Okay? So if you go and really try to combine these two, you will get back the original. So we are just using the formula to help us split it into 3. Can? Yeah, whole thing.
Can we do x equals 0 to find a?
Can. Yes. Can. So you can first start with substituting x as 0. When you sub x as 0, this whole thing is gone. So 5a will be equal to 15. So a is 3.
Miss Wong, how do you get bx squared?
How do you expand?
Oh, okay.
Yeah. Okay, then you can choose other values to sub in like 1. So you will get 8 plus 15, 23. 6a plus b plus c. So you know this is 18. So you form one equation. So sometimes substitution is tougher. That means not say tougher, that it takes more steps. No, x is 0, this whole thing will be 0, right? This one, this thing 0 plus 5 is 5. 5 times a, 5a. Yeah, so it won't zero that out. So you need to sub in another x value, let's say 2, and then you form another simultaneous, and then you solve for b and c. So sometimes it's best you compare some, you sub some, also can. But sometimes it makes more sense to compare because it's easier. Then this one will be more complicated because more steps. Okay, so up to you to choose, but both are equally good method, but sometimes one is more time efficient. Okay, so this is 6. So you realize up till this point, I have not given you any improper fraction. But life is not like that, right? You will have improper, right? So the next example will have improper. So the next few examples, this I will let you do on your own. About 8 minutes, can you do 7? So first step you do is do long division. So if you are unsure how to start, this one unfortunately you need to go and expand the denominator first so that you can do long division.
But it's proper.
Is it proper? Oh, this one proper no need. First one proper no need. Oh, still got proper, so kind. Yes.
So just now this question, I'm a bit confused how you compare the coefficient and constant.
So if you look at x, right? The x term is 3. Where are all my x term? Only this one. So c must be 3 lor. Because left hand side must equal right hand side.
Okay.
So constant term here is 15. You look at this, the only constant term is 5a. So I solve for a. Then the last one is coefficient of x squared, which is 5. Here I got a, here I got b. So a plus b must give me 5. Then you solve.
For this one, is it like that?
You expand. This one is bx plus c because this is quadratic. So on top is a bx plus c.
Okay.
So that means this one you will have to multiply with so here is a bx plus c. change this to BX plus. Then expand. Go toilet. Then expand. Yeah, today straight after school. Okay, do. Try. I shall also work out.
You ever get tired of math?
No. Can do it all my life. Why? Why do you get tired of it?
No, like a bit is fine. A lot is like
Really? I was like, so much enjoyment. Can.
Yeah, no, it's the AX.
Yeah.
For this one, do we need to bring the minus here?
Yeah. Yes. You need two. Yeah.
Why do you sub X?
Anything that I choose. Yeah. One is easy.
If there's no like fixed value,
Then you just plug in any X you want.
If it's an unfactorizable
DX specific.
denominator, it's bx plus.
Yes.
Yeah, you put B, right?
Okay, but
Kamu for everything put B for its unfactorizable.
it's a tiny mistake.
Okay, so essentially it's correct.
And I'm reading over.
Okay, but wait before now, right, you have 8, 9, 10 now. And if you look at it, all of them are, the rest all they expand for you. This one is x cubed plus 3x. Okay? So when do 9,
Wait, what do we wait, compare the coefficients, guys. The coefficients are 8. Compare the coefficient of x.
yeah.
Just now you say after I expand, right?
Mm.
Yeah.
Then you compare.
The sequence
So you can compare minus 3c plus 1 with 3. Because the
There
constant is 1.
constant.
Yeah, constant means no x. So this is the 3. It will be equal to 1 minus 3c.
Then for this square,
It will be a plus b is 7.
a plus b, okay, 7.
Then minus 10 is minus 3b plus c.
Oh,
Yeah.
okay.
My previous understanding.
Yes.
So, like, how do you continue to that?
So this is the one you want to split. So you can take this out and split separately first, then later put back.
Later put this one.
Yes.
Okay.
Oop, time's up. Okay, just to clarify, after you do long division, right, you will pick this out as a separate question and split it first. So that means go and take this out and split it normally first.
Wait, it's actually not bad.
Okay? Then you go and split this normally up. After you solve it, then you put it back in. Okay?
So you just ignore the
Yeah, you ignore first. Just go and split this up. After you split already, put it back in. Yeah. Okay? Let me introduce you to computational thinking. Okay?
Is this tested?
This one not tested, but this is the new thing that that MOE wants you all to know, so that you have an idea of what the symbol represents and what is the process of the solving. So the symbols that they use for programming has a meaning. So if you see this oval shape, right, is usually the start and the end of your program. Okay? And then you see this parallelogram. Okay, usually it's your input and your output. So input is the things that you put in, the information you put in. Output is the thing that you want to solve. Okay? So the processes are all the steps that you take or the method that you do in order to solve it. And finally, the diamond is the decision that you need to make. So let's say if I ask you, is the factor linear? Then yes, you go this direction. No, you go the other direction. So decision is a diamond shape. Okay? So actually, right, the process of problem solving goes through a few things. One is abstraction. That means from the question, you abstract the key information. Okay, and then decomposition is from the big problem. One problem they ask you to solve. There are a few things that you need to solve in order to get to the answer. So you decompose the problem into smaller parts. Okay, generalization is to pick the formula, the theory that helps you to solve this. And then finally, the steps you take to solve it. So the four components of computational thinking are abstraction, decomposition, generalization, and algorithm design. So when you hear this, you shouldn't be very shocked. It's what you do for math when you solve problems. It's the exact same thing, just that the computer do it by the instruction you give them. So how does this look like? So when we feed the system with an algebraic fraction, right? So this is the input. This is the input. You put it into the input parallelogram. Then the computer will feed it into a decision to make, improper or proper. So you then, of course, you went through the process. It is improper because the degree is greater or equals than the denominator degree. Then you go up to this step. You do long division. So this is the process. What method you use to try to solve it. So you break it into its you break it up and make it into a proper fraction. So now you go back in, they ask you, is your denominator factorized? So you will check, oh, my divisor here, is it factorized or not? If it's not factorized, factorize it. Okay, if it's factorized, you can start to express your partial fraction into its respective component. So it's nothing new to you. It's what I taught you just now, the step 1, step 2, step 3, step 4. But computer takes the instruction this way. When you program it, they go through this thought process, you program them to think. Just like how when I went through the steps, I tell you this is the first step, this is the second step. But computer reads this. So you need to know this chart because next time, computing language is your lingo at tertiary level. Okay, so once you reach the partial fraction steps, they will ask you, oh, is your factor linear, non-quadratic, quadratic, repeated, linear? So when it happens, how to split it? And when you finally split it, you solve the unknown by substitution or comparing. And then now you have your partial fractions, you end. Then they give you your answer. So this is what the program do. So you must know what all the symbol means. At least you know the language. When we apply this, it wouldn't be foreign to you. Yes. This one is output. At the start is your input. Yeah. Okay, all these green ones are the processes. What are the method you take? All the diamonds are your decision. Okay, yes or no. Okay, and then yeah. So there's only 4 different legends you will see in a computational thinking language. Okay. So can okay, I think there will be 3 of the students in this class, which is Qi Hui, Zihan, and Ben, right? They will be going for a workshop, a 3-day workshop competition, okay, on computational thinking. Okay, so they will learn intensively there what is this thing about. When they come back, they will share with you all what they have learned. Okay. I think Python. Yeah. Okay, so they will teach you a bit of the Python lingo, and then when they learn, right, they come back and they will share with you all what they have learned there. Okay, so this is the thing. Okay, of course with AI, you can feed the info into AI and ask AI to come up with the Python code for you. And then you run it in the program in future. But it's important to at least know what they are writing. Yeah, so that when you need to debug, although you can ask AI to debug for you. Yes? How would you raise your hand? No. You have to memorize it.